Okay guys, are you ready to learn? Get your computer, get your pen, get your paper, and begin to jot things down because we are going to learn a lot.
Do you know why I asked you to get a pen and a paper? Because you need to jot things down in order to be able to take things away.
Now, before we delve into the technicalities of what Git is, what GitHub is, you have to understand that all these are part of a system known as version control. Say it after me, version control. Okay, so whenever you hear Git, GitHub, or anything that pertains to it, it falls under the broad umbrella of the subject known as version control. But before we delve into the very technicalities of talking about all that, let me use a chessboard, okay, a chess game as an analogy to explain version control. Now, what do we do when we are playing chess? We move pieces around. So, assuming you and I were playing chess, but we were so slow in playing the game that we are going to spend an entire day sitting behind the board playing just one game.
How?
Now, what's going to happen is that we cannot sit behind the board for the entire day just playing the game. We are going to get tired. At some point, you have to visit the washroom. Not me, you have to visit the washroom, and then at some point you have to pause and find something to eat, and then we may have to pause for other reasons. So what happens during the moment when we pause? What if someone comes to move the pieces around and move the game in your favor?
Come on now, dog.
Or someone comes and knocks the board over and our pieces scatter. Then what do? How do we solve this problem? What we can do is that at every moment when we pause to go do something, whether to eat or to visit the washroom or anything, we can take a snapshot of the game. So let's see what I mean. Okay, so let me just draw up a very nice chessboard. Okay, so this is a very nice chessboard that I just drew up for us. So assuming we went on our first break of the game at 8 a.m. Okay, so what we are going to do is that we'll take a snapshot of the game. So at 8 a.m. the game had a certain configuration. All right, then let's say at 12 p.m. we went on another break, so we took a snapshot of the game. And let's say at 3 p.m. we were tired, so we went on another break, we took a snapshot of the game. Then at 6 p.m. we went on another break, so we took a snapshot of the game. Then at 9 p.m. we came to complete the game. So what happens is that in the entire scope of the game, we are going to have 1, 2, 3, 4, 5 snapshots. Okay, what is going on here? You're going to realize that we have various save points of our game. So we can decide that why don't we go back and play the game exactly as it was, as the configuration was from 8 a.m. Or we can say that why don't we arrange the pieces on the board exactly as they were at 3 p.m. and let's play the game from that point forward. So this gives us the power to have various save points of our game, and we can decide to arrange the game exactly as they were at various times during the day. This is what version control is. It's very simple. This is all version control is. So when we extrapolate this into source code management, then you understand that it is simply us controlling various versions of our code across time. Just as in this chess game, we are able to control various versions of our game across the span of time. Very simple. This is what version control is. So we are going to delve in and understand the technicalities of this and how to implement it in code. Okay. So, version control is simply a system that helps you keep track of changes made to a project over time. It allows you to maintain a detailed history of the project, as well as the ability to work on different versions of it, just like we could go back and play our chess game from any of the snapshots. This is version control. So now, the principle of version control, or the idea, the concept of version control, is what is used for source code management. And source code management refers to the process of managing changes and tracking modifications made to a shared code base. So you and I are working on a project. I see you and I working on a project sometime in the future.
Okay.
So we are working on a project. We need to be tracking our project. So how are we going to track it? We need to track it with a version control system. There are several examples of version control systems, but the most common currently are Git, Subversion, and Mercurial. But in this course, we are going to be focusing on Git version control system. All right. Now, apart from the various kinds of version control system there are also the models of version control. All right. Then in talking about the models, the two most common are the centralized model and the distributed model. What do these mean? So we have the centralized model, and then we have the distributed model. For the centralized model, we have a huge computer sitting somewhere, and then there are the developers that are working on the project on their various computers. Then each developer communicates with the central computer before they are able to track their project. All right. Now the disadvantage about this is that the moment this central computer goes off, now you cannot access the project. You cannot track your project with version control. So that's the disadvantage about the centralized model. Then there is the distributed model where every developer has access to the project. So with a distributed model, each developer has a copy of the entire project on their PC. So let's say this is me, Leo, this is you, this is GitHub. We'll talk about GitHub in a bit, and this is another developer. All right. So you're working on the project. I'm also working on portions of the project. So you push your changes to GitHub. I push my changes to GitHub. This one pushes their changes to GitHub. I pull your changes to my local PC. You pull my changes to your local PC. This developer also pull their changes to the local PC. So what happens is that at the end of the day, all of us are going to have the very exact same copy of the project. And this is what makes distributed version control very powerful, because every developer or collaborator has the entire code base, has the entire copy of the project. If let's say my PC gets damaged and I lose my code, I'm not afraid, because you also have the entire copy of the code. And then we have also uploaded the entire copy of the code on GitHub. So all I need is a new device, and I'm going to just pull everything back to my local PC. And this is what makes distributed version control extremely efficient. So as you can see, with the distributed model, each developer has a complete copy of the project. So having understood all these, we can now talk about Git. Git is a widely used distributed version control system. You already know what version control is now. Git is a distributed version control system. It helps us to track changes to our source code during software development. It's as simple as that.
Nothing new, nothing changed, same old.
With Git, each developer has a copy of the entire code base, just like we said, on their local machine, and changes made to the code base are tracked and recorded in the form of commits. You understand what this means in a moment. Let's take it one step at a time. So now that we are talking about Git, I am also sure you might have heard about GitHub. What is the difference between Git and GitHub? Now remember that you have the Git version control system, which you are using to track your project. Okay, so it's like you are using a Git version control system to take snapshots of your game. Just like we're taking a snapshot of our chess game, the Git version control system is what we are using to take these save points or these snapshots. Okay, this is happening on your local PC. However, GitHub is a system by which everything you have tracked on your local PC, you can push it into the cloud. So assuming you lose your code locally, you can always go back into the cloud and fetch it back or pull it back. So over here, I say that GitHub is a web-based platform for hosting and collaborating on software development projects that use the Git version control system. So all the snapshots that we've been taking throughout the game, now we are going to save it somewhere, so that just in case something happens to our phone, we can always have it back. That is what GitHub is. Very simple. And don't forget that I also mentioned that GitHub is also used for collaboration. And we are going to go into this a lot today. Collaboration. I'm going to teach you how to collaborate with other developers on the same project. I'm going to teach you how to contribute to open source projects. I'm going to teach you how to create pull requests. I'm going to teach you how to fork a repository.
What? Bro, what are you talking about, man?
You're going to understand what all these mean by the time you are done with this course. Okay, so let's proceed. Now, before I delve into the technicalities, there are 5 very key terms that you need to understand, because I'm going to be using these terms throughout this entire course. So get your pen, get your paper, and jot these 5 things down. We are going to need it throughout the span of this course. Okay, and these 5 terms are the working directory, the staging index, a commit, a repository, and a shard. These are 5 key important terminology in Git. Let's take a minute to understand what these mean, then we get our hands dirty.
My time has come.
The first is the working directory. Now, if you know a little bit about Shell, you understand that there is something called the working directory. But in Git, the concept of the working directory is not the same as the concept of the working directory in Shell. In Shell, the current working directory is the directory that your shell is looking at, is focused on. But that is not how it is in Git. The working directory in Git is that location that has the entire base of the files that you are modifying. Okay, so the working directory in Git could have directories with files in them that you are modifying, and then it could have files that you are modifying. This is a little different from the working directory in the shell. So Git working directory, I'm going to illustrate it to you in a minute, so don't worry, just follow me one step at a time. So the Git working directory has all the files that you are modifying. So whatever you think about the working directory in Git, think about modification. Let it stick in your mind. I said what? Modification. In the working directory, we are dealing with what? Modification. Okay? So you see here, I say that you work with files in the working directory. As I go on, you can pause the video and then read through, because we don't have the time to be reading through everything. So as I explain stuff to you, what you can do is that just pause the video, read a note, pause the video, read a note. And what I'm going to do for you is that I'm going to leave the link of this notebook in the description down below, so you can have access to this notebook and then read on your own. Okay?
Perfect.
Then after the working directory, we have another area called the staging index, or the staging area. This area stores information about what will go into your next commit. Think of it as a prep table. So assuming you are preparing cake, the table on which you have put the cake that is about to go into the oven, that is the staging area. It's a prep table. All right, it's as simple as that. Then we have what is known as a commit. Commit, like the way a man will commit to marry a woman. Commit to me. The girl will tell the boy that, commit to me, I want your commitment.
Women.
Okay, what is a commit? All right, a commit is simply a save point in your project. Think of it as the snapshots we spoke of in the chess game. So remember our chess game, all the snapshots that we took were making commits. So a commit is simply a save point in your game. It's like a snapshot in your game. You get it? Okay. Then we also have what is known as a repository. Repository. And this stores all your files as commits. It can exist locally on your computer or remotely on another computer. So all the snapshots of our chess game that we have taken, if we had a certain location in which we stored it, then that is the repository. So the repository stores all our snapshots. You can have it locally on your PC, or you can have it remotely in the cloud. Very simple. Are you learning something? Finally, let's talk about our SHA. SHA. Now, SHA is simply an acronym for Secure Hash Algorithm. Secure Hash Algorithm. All right. Then this is an ID number for each commit. Okay. So, for instance, for our game that we played, which I won.
The game is broken, EA Sports. The game is broken.
we had 5 snapshots throughout the entire span of the game. But remember that each snapshot has an ID number. So the first one is 1, 2, 3, 4, 5. Okay, so all these ID numbers is what is known as the secure hash algorithm, or the SHA for short. The SHA for short. Now typically this is what a SHA looks like. You see these characters over here? This is what a SHA looks like typically. This is it. It's a random string. And you are going to see several of these as we proceed. Don't worry if you don't understand what is going on yet. Just a poco. That's a Latin word for little by little. Okay, one step what at a time. Let's go one step at a time. You're going to be a master, a pro of Git and GitHub. If you take your time and watch this course, by the time we are done, Git and GitHub is just going to be your friend. I'm telling you, just take your time. Trust me. Let's go.
Good job.
So far, this is what we are speaking about. Now, let's divide our board into 3 parts. So we have this, we have this, so we have this, and that. Okay. So we said that we first have the working directory. Then we have the staging index. Then we have our repository. Okay. So assuming we're working on 2 files in this place, okay, let's say we have this file, let's call it an HTML file. So this HTML index.html or something, and we have another file which is a CSS file. This file is in our working directory. We are making changes to it. Okay, so we have our HTML file. We have written stuff in here, creating a very beautiful structure for the web app that we are creating. Okay, then we have our CSS. We are styling our structure, very beautiful colors and background and everything. Okay, we are making modifications to the file. Now in the Git system, what is happening here is that every modification you are making is being tracked in the working directory. So we are playing our chess game, we are moving the pieces around, the queen is attacking the bishop. Okay, all that is happening in the working directory. So let's say now we want to pause the game and go find some food to eat. Okay, so we just get up and we are getting ready to take a picture. All right, we have taken our phone out, we are ready to take a picture of the game so that we can pause. So at this point, what we are doing is that we are staging the game. The game is ready to be captured. Okay, so that is what it means to move it to the staging index. Okay, so there is a command that we are going to know very soon. When you type in that command in Git, it moves the files from the working directory into the staging index. That is a prep table that we spoke about. Okay, so the files that you have modified over here, you run the command git add and you move them to the staging index. But the files are still here, just that they are not modified files. They are still in working directory, just that they are no more modified because you have moved them to the staging index. Okay, then you run another command and this command moves the files into the repository. So this command moves the modifications that we have done. We have taken a snapshot now, and then we are moving the snapshot to the location in which we want to store it. So this is the first snapshot of our chess game. All right, and that represents the modifications we have made to our project. So the project that we are working on, we have made some changes to it, and then we have taken a snapshot of the current state of the project. We have stored it in a safe location in our repository. That is the workflow of Git. So let's say we come here and we make more changes. Remember I told you that the files are still here. Okay, so we have our HTML file, is still here, and I have a CSS file which is still here. Just that this time around we've not modified them, so the files are still there. We have captured the modification we made and we have moved it to the repository. So in our working directory we don't have any modified files. So we come in again, we add maybe a footer, we add a form to our HTML file, we made some changes to it, then we color it in our CSS file, we made some changes to our CSS file. You get it? Then we run the command git add, then we move all these files to the staging index with the command git add. We'll talk about what it means in a moment. We git add, we move them to our staging index, then we git commit, move them to the repository. So we have taken 2 snapshots currently. All right, so let's say this first snapshot that we took of our project, let's use another color. This first snapshot that we took of our project, remember that it has a SHA, the secure hash algorithm. So let's give it an ID of 1. Okay. Then this second snapshot that we took of our project, let's give it an ID of 2. All right. We are still working. So we still have our files here, our unmodified files. This is our HTML file, and this is our CSS file. Let's take a test snapshot. This time around, we are not going to touch the HTML file. We just make some modifications to our CSS file. The HTML remains unmodified, okay, untouched. So what happens when we get add now? We are not going to move the entire set of the project files. We only move modified files to the staging index when we run the command git add. Okay, so because we only modified our CSS file, we are going to move it with the command git add to the staging index. Then we get committed to our repository. So we have a third snapshot now. So let's give this third snapshot an ID of 3. So as you are seeing, this is the workflow of Git. You are working with your project files in the working directory. You run the command git add. You move your project files which have been modified to the staging index. You run the command git commit, and then you move your staged files to the repository. But all this is happening in your local system. Okay, so that is not all. Let's say that now you want to push your project into the cloud. You want to push your project to GitHub. So what happens is that all the snapshots that you have taken, you can actually push them with the command git push. We are going to understand how to do all these things, and you push it into the cloud, into the hosting platform which we've spoken about, and that is GitHub. So when you run that command, you move your entire repository, or you copy your entire repository, and then you move it into the cloud to GitHub. You get the workflow. And when you move your repository to the cloud, it doesn't mean that you have lost it in your local system. It is still here. You just make a copy of it into the cloud. Does it make sense? If everything is looking complicated, don't worry at all. We are going to break it down as we proceed. So now that we understand the workflow of Git, let's just go and find out, how do you have Git on your PC? How do you install Git on your PC? Whether you're on a Mac, a Linux system, or a Windows system, how can you have Git on your PC? Now the good thing with Mac users is that you already have Git installed on your PC, so you don't have to worry about installation. If there's anything you must worry about, is probably upgrading or updating your current version of Git, but you already have it installed in your system. So if you're on a Mac, you don't have a problem. But if you're on a Windows, you have to go through the installation process and make sure that you have Git installed on your system. Okay, so let's just run through Mac installation just in case someone doesn't have it, and then also just in case you want to upgrade your Git on your Mac. Let's find out how to do it. The first thing you want to do is to open your terminal and check if you have Git. Okay, so let me just go straight into my terminal. What you want to do is to run the command git version in small cases. Then if you see a certain version pop up, it means that you already have Git installed on your PC. I said, as of the recording of today's video, this is the most recent version of Git. So if you check your version and you have a higher version, it's probably because you are in the future. Okay, congratulations, future self.
2,000 years later.
All right, so run this command, find out if you have Git installed on your PC. If it's a lower version, you can decide to upgrade it. And there are several ways by which you can have Git on your Mac. We are talking about the Mac installation now. If you're on a Windows, just skip. I'm going to leave a link in the description below if you're on a Windows, how to get Git installed on your system. Okay, so if all these don't apply to you, just skip to the portion of the video where we start using Git itself and forget about the installation process. Okay, but if you don't have it, then just take your time and then go through it. So what you want to do is to visit this website, Git Source Code Management. You remember we spoke about source code management. So gitsourcecodemanagement.com/downloads. Okay, /downloads. So when you visit that website, it's gonna bring you here, and then you can choose the one that applies to your operating system, whether a Mac, a Windows, or a Linux system. Because I'm on the Mac right now, you're gonna click on the Mac, and then there are about 5 main ways by which you can install Git on your PC or upgrade. You can go by the conduit of Homebrew. You can use Macport, you can use Xcode, binary installer, or you can build it from source. But if you're an absolute beginner, don't even try building from source. The binary installer is a very effective way, and the installation process is really straight to the point. I usually advise people to go by the way of Homebrew because it's very cool. If you don't have Homebrew on your PC, you first need to install Homebrew. So you need to check if you have Homebrew by running the command brew-v. If something pops up like this, it means that you have Homebrew on your PC. It might not be the same version because it might be lower or ahead of this version. But as at the recording of this video, this is the most current version of Homebrew. But you may be in the future, so you have a higher version, or your version may be lower, okay? So you may want to upgrade it. So if you don't have Homebrew, what you want to do is to go to the Homebrew page website, then copy the link over here on their website and go and run it in your terminal. So I just copy the link, you run it on your terminal, and you enter. Then it's asking for my password, so I'm just gonna enter my password. So as you can see, it's saying that this script will install all these things, but I have already installed Homebrew and I have the current version, so I don't have to install it again. So I'm going to abort the installation process. But if you don't have it, just continue the installation process and have Homebrew installed on your PC. When you are done, just run the command brew-v to see if you have had Homebrew installed on your PC. Alright, that's good. Then when you are done with that, you now want to come and run the command brew install git. Brew install git. So you go into your terminal and run this command in there. Just clear it out. So you see, because I already have Git installed on my PC, it's telling me that Git 2.41 is already installed and up to date. To reinstall, I have to run this command. I'm up to date, so I don't have to reinstall Git. But if you don't have the current version and you want to upgrade it, it's just your choice. You can use the old version, nothing's going to change. Then run this command and then you can continue with the course. Okay, so I'm clearing my screen, and when you are done, you want to run the command git version to find out if you have Git on your PC. Or you can just type the command git, and if all these things pop up, it means that you have Git on your system. You are ready to fly. Now, if you're on a Windows system, I've left a link in the description below that will run you through the installation process. It's very simple and straight to the point actually. All you have to do is to choose the setup for Windows and choose the one that gels with your operating system. Usually it's a 64-bit for the recent systems. Just click on it and download, and you just have to click next till you install it. It's really straight to the point. But just to help you, I've left a link in the description that will run you through the installation process. Okay, so let's go straight into learning how to use Git proper. Okay, at this point I can safely assume that you have downloaded Git and you have it working in your system. Now usually the first thing you want to do before you start using Git is to configure it with your username and your email address. Okay, so let's configure your Git with your username and your email address. What you want to do is to run the command git config-l. Okay, you're gonna see all these things. You may not see the same thing here, but I have configured my Git with several things, and there are two of them that I want you to currently focus on right now. Forget about the others, just let's focus on two of them right now. Okay, and these are your username and your email address. So we are going to configure your Git with your username and your email address. Don't worry about all the rest that you see. There are additional configuration settings that I have done. We are going to talk about them much later. Okay, so run this command in your Git. If you're a first time Git user, run git config --global user.name, and you enter your full name in quotation marks. Okay, now I usually emphasize that enter your full name, and this is because you may be in a team with other developers and someone may have the same first name as you. So if you enter just your first name and we check the log of the project and we see maybe Leo and another person is called Leo, then how do we differentiate which developer made that commit? So it's usually better to enter your full name so that we know which developer we are dealing with, and you understand why this is important very soon. Okay, so just run this command and enter. When you are done, run this command again, git config --global user.email. Then enter your email address in quotation marks. This is my email address. Wonderful. So after you have entered, now you want to check if your configuration has worked, and you run the command git config-l. The moment you see your username and your email address in there, your Git is properly configured, and then you can start using Git version control. So this is what we're going to do. Let's create 2 directories. Then we are going to use those 2 directories for our course, for our tutorial, to learn a lot of things. We're going to be using it to initialize Git, to push commits, and to do all that. So let's create 2 directories. Let's create a directory and create another directory inside it, okay? Because we want to use it to do something. So let me clear my screen now, and let's make a directory. If you don't understand this command, it's simply a shell command, right? ls pwd mkdir, and I have an entire series on this same channel for you on Unix shell scripting. So you want to take time after watching this video and go through Unix shell scripting. If you can't go through the entire series, then just go through 40 must know Linux commands. After that video, you should be good, at least with the basics of Unix shell scripting. It's a very wonderful video, and I encourage you to watch it. So I'm going to use this command to make 2 directories. So mkdir-p, let's make a directory. Let's call it git course, or no, let's rather call it tutorials. Then inside that directory, we want to make another directory and call it git course. And let's also cd into it. We are changing directory into it. Okay, so let's cd. If you don't understand this command, do not worry, it's a shell command. Basically what I'm doing is that I'm creating a directory and creating another one inside it, and I'm changing directory into it. Okay, so when I do that in ls, you can see that I'm already in the git course directory. Let's view it in a graphic user interface so that it makes sense to us. So I created a directory called tutorials. Let me magnify it. Yes, I created a directory called tutorials, and inside it I created another one called git course. Then that directory is empty, as you can see. So when I ls, there's nothing inside it. It's an empty directory. All right, now once again, I encourage you to watch my video on shell scripting. It will give you a good grasp on shell commands. Okay, so if that command is a little complicated for you, just make a directory. All right, give it any name, and then change directory into it, then make another directory inside it, and then change directory into it again. It's just a long process. That's how come I use this one. All right, so what do we do now? Now that we are inside the git course directory, we are about to convert it into a Git repository. Okay, as you can see, that directory is completely empty. There is nothing inside it. So to convert a directory into a Git repository, you use the command git init. Okay, git init. Now let's enter. You're gonna see all these things popping up on your screen. Don't worry about them, but what you need to do is to read the very final part of it, which says that initialized empty git repository in, then they give the path all the way to the file. Okay, initialized empty git repository. So as you can see, we just run one command and we have initialized a git repository. But what has happened to our directory? Has something special happened to it? You're gonna see something. Now suddenly you are seeing that there's a word master which has popped up here. Don't worry if you don't understand what that means yet. I'm going to explain that in a bit. Let me clear my screen and then ls, and let's see if there's anything inside this folder. And as you can see, nothing popped up. It's an empty directory. But really, is it an empty directory? Let's go into my graphic user interface and see. There's still nothing in there. But when we use the shell command that lists hidden files, you're going to realize that actually when we initialize Git, something was put in that directory. So let's ls and use the flag -a. The -a flag helps you list hidden files in any directory. Okay, now when we enter, you can see that actually there was stuff in our empty directory. Okay, now we see this .git directory here, and we didn't create it, but because we initialized Git in this directory, a new directory has been created for us. Let's go view it in a graphic user interface and see. The way to do it is use Ctrl Shift and you press period, or on the MacBook, Command Shift period dot. So as you can see, there's actually a hidden directory in there. Can we open it and see what's inside it? Sure. Let's investigate and be adventurous. So now I open this directory, and as you can see, there are so many directories and files in there. But we didn't create this. But all this came about because we used the command git init. Git init. That is how you initialize an empty Git repository. And all these files and directories that you see are configuration files that are going to be used to track your project using the Git version control system. Now I must give you a note of caution. Don't edit the files in here. If you edit the files in here, you might end up crashing your version control system, because these are the configuration files that are going to be used to track your project. And the moment you start messing with them, you can mess up your entire project. So don't touch these files. There is a reason why it was kept as a hidden file. Okay, so later on we are going to understand what this config, description, head, and all these things mean, but that is not for the scope of this course. Okay, but then if you go through my notebook, I've actually explained what these things do. So make time, you can pause the video, go through the notes, and then understand what these files do. For instance, the config file is where all the project specific configuration settings are stored. And then these other files do these things. So you can take your time, go through the notebook, and then understand a bit more. But you really don't need to understand these things to get a grasp of version control. So don't worry about these things for now. Okay, jump these steps, and then let's talk about more important things. All right, so as you can see, we have our .git hidden directory over here. Anything you see, any directory or file you see starting with a dot, means that it is a hidden file or directory. All right, so let's be bold and cd into it, just like we did with the graphic user interface, and then let's ls and see. So you can see that all the files that we saw in the graphic user interface over here are actually in the .git directory, and these are configuration files that will be used to track your project. So now you have initialized an empty Git repository. This is the first way of doing it. Now the second way is to create a repository in GitHub. Then you clone the repository to your local system. So we are gonna do that too. Okay, so let's change directory out of here and go into our tutorials directory. That's where we came from. All right, great. So over here too, let's just go back. We're gonna come back into our tutorials directory, and then we're gonna clone a repository into it. You get it? All right, so to do that, let's just go to GitHub. Now if you don't have an account at GitHub, just go to github.com and then just create an account with them. It's pretty straight to the point. Okay, so there are two ways of creating a repository. You can click on your avatar over here and just come to my repositories, and then click on that and create a new repository. Or you can see this plus sign over here with this arrow, just click on it and then come to a new repository. All right, when you click on that, it's going to bring you to this interface, and then you enter the name of the repository you want to create. So let's call this Git Repo 2. The name is available. Okay, so you can decide to give it a description. What is your project going to be about? You put that in the description area. I'm not going to give it a description right now, and don't worry about adding a readme, because we are going to add our own readme to it. Okay, then you just scroll down and create a repository. Now this is going to be an empty repository. There is nothing in here. So when you see all these things written here, don't worry about them. It simply means it's an empty repository. Okay, but all these instructions here are actually telling you something. There are some things that we are going to give attention to here. If you look at this one, it's simply saying that git init. If you don't have a repository, you realize that it's saying that git init, and this is the command that we use to initialize the repository in our local system. You get it? So then we could add a readme, and then we can make commits. We're going to come to all these. So these are just initial commands that GitHub is trying to help you with to get yourself familiar with the Git and GitHub system. But then that is not what I want you to focus on right now. Do you see this URL over here? I want you to copy it. You can either use the HTTPS or the SSH, but forget about the SSH for now and then choose the HTTPS. Copy that URL, come into your terminal. Let me clear my screen here, and then enter the command git clone, then paste the URL. You see it? When you are done doing that, just enter. As you can see, it's saying that cloning into Git repo 2. Cloning into Git repo 2, and it says that you appear to have cloned an empty repository because truly it's empty. There is nothing inside it. Now when I list the files inside my tutorials directory, see what happens. Now I have the Git course which I initialized locally, and I have another repo called Git repo 2 which I cloned from GitHub. So two things are happening here. I created this directory and I initialized it as a Git repository, and then this second one I cloned it from GitHub. So these are the two ways that you can initialize repositories. Either you use the command git init to initialize one locally, or you clone one from GitHub. Now take note that after we cloned this repository from GitHub, it took the same name of the repository in my GitHub account. Okay, so in my GitHub account, the name that I gave to the repo was Git repo 2. Now when I cloned it to my local system, the same name Git repo 2 was given to it. But what if I wanted to change the name? Of course I could have done that. Then I would have used the command git clone, and after I paste the link, the URL, then I'll enter a new name which I wanted the repo to have. So just in case you are cloning a repository and you want to change the name, all you have to do is to enter the command git clone, bring the URL, that's a link which you copied from GitHub, then enter the new name you want the repo to have locally, and then it's going to have a new name. Okay, so now if I change directory to this Git repo 2 and I list with the command that lists the hidden files, you are seeing that this same .git directory is also in the repo that I cloned from GitHub. That means that it is set up with configuration files to track anything you do in the repo. Okay, so let me clear my screen now. You can see that I've changed the directory into this Git repo 2. How do you know what is happening inside your repository? Now that Git version control is being used to track your project, how do you know what is going on in there? The command to use to inspect your repository is git status. So we enter this command and it tells us that we are on the branch main. We are going to talk about branches very soon. And then it says that we have not made any commits yet, and there is nothing to commit, which means that there is nothing being tracked. This simply means that we have done nothing inside our repository as yet. Okay, let's change directory out of here, and now let's change directory into the first repo that we created. Let me ls. Let me clear my screen and ls. So I'm going to change directory into the Git course repo, okay, which we initialize locally because we want to also inspect that. Great. Now, like I said, to know what is happening inside a repository, you use the command git status. And as you can see, it says that we are on the branch master. We've not made any commits yet, but we have a certain untracked file. Now this file really doesn't mean anything. You usually see it inside a directory when you initialize a repository locally, so don't worry about what it means. What we are going to do now is that we are going to create some files and edit them. Now in every Git system, you need to understand that you need to choose your IDE, that is your integrated development environment, or simply your code editor. I work with VS Code. you can choose to work with any other editor. Some people prefer Sublime Text, others prefer Atom, or others even prefer the default VI editor in the shell. Any of them is okay. But if you're going to use any other editor, you need to configure your shell or your Git to that editor. So because I am using VS Code, I've configured my Git with VS Code so that they can work hand in hand. If you have VS Code, then there's a command you need to run to configure your Git or your shell to the editor so that they can work hand in hand. I'm going to leave a link in the description below that will help you configure Sublime Text and Atom. But if you are going to be working with VI, then it's the default, so you don't have to worry about anything. It's just going to happen automatically. So because I am on VS Code, this is the command to use to configure your editor to your Git. Git config -- global core.editor -- wait. So what you want to do is that this link is in the description. You want to copy this and then run it in your code editor. That is if you are using VS Code. If not, then there are other configurations down there. You can use it to configure your editor. Okay, so because I have configured my shell with VS Code, the moment I type code, it's going to open VS Code. And as you can see, it has brought me straight to my Git course repo, right over here. Okay, so back to my shell. Inside my Git course repo, I'm going to create some files and edit them, and then let us observe how Git version control is used to track these files. All right, so let's just go into my VS Code. Let me push this forward a bit. Great. Let's create a file. Let's call it index.html. Awesome. Now inside that file, let me just magnify it a bit. Let me add some random HTML text. As you can see, this is just the format for an HTML file. We have the HTML element, and then we have the body element, we have the head element. It's just basic HTML. Okay, so inside the body, let's say a header. Okay, let's add a header. Let's call it Git course. All right, and I'm gonna save the file. Let me clear my screen, my terminal. Let's see. So I'm gonna list the files in here. You can see that the file that I just created is showing up here, which is index.html. All right, now I'm going to type our favorite command right now. Our favorite command is git status. Okay, I'm gonna type the command git status so that we can see what is happening in our repository. Now I enter, you can see that it says that now I have another untracked file, which is the index.html file that I just added. And just like I explained to you, when you are working with Git, all the files that you are modifying are in the working directory. So I just added an index.html file and it is registered inside the working directory. So my index currently is inside the working directory. Okay, so now we are going to run a command and we are going to move it to the staging index. All right, so let me clear my screen here, and then I'm gonna get status again so that you can see that we have untracked files over here. Let's run the command git add, then a period. The period over here simply represents the current directory that we are in. So if you use the period, it means that every modified file in the current directory is going to be moved to the staging index. If you do not want to add all the files in the current directory, then do not use the period. The moment you use the period, all the files in the working directory, the current working directory, are going to be moved, which you have modified, are going to be moved to the staging index. That is all the untracked files. So if you do not want them, then you have to list the name of the files. So in this case, we could have just listed index.html. Then I'm going to enter. Then what command do we enter again? Git status. The way to know what is happening in your repo is to run the command git status. That is very important. You always want to run git status. I remember a lot of people were coming to me, Leo, my Git is not working. My Git is not working. What's the problem? What's happening? The question I asked them is that, have you run git status? Whenever your Git is in a certain state, git status is what tells you what's happening in your repository. So let's run it, git status. You see, now things have changed. This file, index.html, which we just added, has been moved to the staging index. So if you look at this place, it says that changes to be committed. That means that, use the chess game analogy, the changes that are about to be snapshots. We are about to pause the game. The changes that are about to be snapshots. Okay, so we have used the command git add to move the index.html file from the working directory into the staging index. So now our file has been moved from here and it is over here, index.html. Okay, so how do you move the file into the repository? That is, how do you take the snapshot actually? How do you make a commit? Remember, we spoke about commits. The commit is the save point. The commit is a snapshot that you're about to take in your project. How do you make a commit? You use the command git commit. If I just enter git commit and I don't enter anything and enter, it will automatically open my default code editor. Then I'm going to supply a commit message. Okay, I'm going to supply a commit message to this change or to this modification that I just made. But then if I don't want the default code editor to be used, then I'm going to use the flag -m, which means that this is the commit message that I'm supplying. And usually the de facto commit message for every project which is just starting is initial commit. Look at the syntax very carefully. Your commit message is in quotation marks. Your commit message goes in quotation marks. Okay, so the command is git commit -m. The -m represents a message. That's the commit message. Then you bring your commit message in quotation marks. Then you enter. So as you can see, we see the commit message over here. Then it says that we are on master, the master branch. We'll explain what the master branch is in a bit. Then you can see that it says that one file changed, 12 insertions. Then the file that has been edited is index.html. All these info over here are in the single commit that you made. Okay, so let me clear my screen and run our favorite command again, git status, and let's see what it says. It says that we are on the branch master. Now the index.html file has been moved to the repository, so it's no more part of the untracked files. Don't worry about this ds store, we can just delete it. And then it says that nothing added to commit, but untracked files are present because of this. Okay, so let's go into the file system and then make more editing. Let's edit a few more files and then let's see how Git tracks it. Then when we are done, we're going to inspect our repo again and see what is happening. So I'm just gonna go into my my code. Let me just change the heading to, let's say, git course updated. Okay, git course updated. Now I've modified the file, as you can see. Let's say I want to add another file. Let me just add a CSS file. Okay, so I'm gonna call it app.css. And let's say I want to color my h1 file as, let's say I want to make it red. Okay, wonderful. So now I've made a modification in my HTML file. I've changed the heading to git course updated. Then I've added a second file which is app.css, and I've made our heading red. Don't worry if you don't understand the code that's going on in here. Don't worry, our focus is not front-end designing right now. Our focus is Git version control, so you don't have to understand every code in here, right? So let me go into my terminal now, and I'm going to run our favorite command, git status. And as you can see, it is telling me that I've modified index.html because I did, and I've also added another file, app.css. So you are seeing that now, because we are using Git version control, everything I'm doing is being tracked in the system. So when I make modifications, I'm making them in the working directory. They are moved to the staging index when I add, and then they are moved to the repository. Okay, so let's git add. Let me clear my screen, and let's git add. This time around, we use the period, indicating that everything in the current working directory, we want to move it to the staging index. Okay, so I git add, and then I enter the command git status, and as you can see, all the files in that working directory have been moved to the staging index. So let's say I move a file to the staging index, but maybe I did it by mistake. I want it to be brought back to the working directory. How do I do that? Now you can see that Git itself is helping you to is teaching you how to restore a file. So we have moved our files to the staging index. Now we want to bring it back to the working directory, and Git says we can use the command git restore -- stage. Then we bring the file name. So let's try it out. I'm going to copy this command and paste it, and then I'm going to unstage the CSS file. Let's say I want to unstage app.css. Now when I enter in git status again, you can see that I have unstaged the app.css file. You can try it in your own terminal. So you can move a file to the staging index, and you can bring it back to the working directory, back and forth. So now let's move the app.css file back to the staging index all over again. So we're gonna get add, then which file are we adding? App.css. Now when I enter, I'm going to git status. You can see that now the file has been brought back to the staging index. Okay, so let me just git commit -m. Alright, and I'm going to supply a commit message. Let me just supply a random commit message and say add CSS. I'm going to talk about what makes a good commit. What I just did by adding a change in the HTML file and then adding another CSS file is not the right thing to do. Actually, it is more appropriate to make your commits specific. So if you want to make a change in the HTML file, make that change and then push it as a single commit. If you want to make a change in the CSS file, make that change and then push it as a single commit, but you don't mix up many changes as one commit. Later on, you're going to realize that is going to complicate your Git structure. You might find problems in the future. So just because we are starting out, I want you to understand how the system works. So I'm just going to push this commit and then we're going to see what happens. So I'm going to say I add a CSS file. Remember, a commit message is supposed to be in quotation marks, all right? So I do that, and it says that if you look at the details in here, this is my commit message, 4 insertions, 3 files changed. What are those files? The HTML file, this DS store file, don't worry about it, and then there is the app.css file. Now if I get status again, you can see that I am on branch master, nothing to commit. My working tree is clean. Awesome. So now we have seen how you can modify files in a working directory. You can move files with the command git add to the staging index, and you can move files with the command git commit to the repository. That is well understood. But how do we inspect the history of a repository? Let's say we come to a repository, we are not the only one working on it. We want to know what has gone on in the repository from the beginning of the project to the present time. How do we inspect the history of the repository? Okay, so I'm going to clear my screen. The command you use for that is git log. Okay, so if you look at it carefully, this is the first commit, the first snapshot that we took. This is the first commit that we made. Then there is the date of that commit over here. Then there is the author of the commit, which is me. And then you can see my email address right beside my name. Now remember, I also spoke to you about the SHA, which is the secure hash algorithm, the ID number of the commit. Now this is the SHA of this particular commit. So in this repository, as you can see, we don't have many commits. There are repositories that have thousands of commits, and if you clone the repository and run git log, you're going to have all these commits, their commit messages, their commit date, the commit author listed in your command line. This is the power of the git log command. So as you can see, this is the second commit that we made, and you know the commit message is add CSS file, just like we did. And then you can see the author of the commit, the date of the commit, and then the SHA of the commit. But then there's one more thing I want you to see. There is this thing here called head, and it is pointed at something called master. Okay, it is pointed at something called master. I'm going to explain that in a bit. It has to do with what is known as Git branches. Git branches. But before we come to talking about Git branches, let us explore a little bit more about commits and then secure hash algorithms, their SHAs and their dates, to understand it very well. So in order to do that, I'm going to clone a repository from GitHub, which I've been working on for a while. Then we are going to run the git log of that particular repository, and then we are going to see how an active repository's log looks like. Do you agree with me? Okay, so let me do that. I'm just gonna clear my screen. Then let me just cd out of here into a repository which is a very active repository. Wonderful. So this is one of the repositories I have in my GitHub. It is Flax Notes. It's actually programming notes if you go into my GitHub, and I've been working on it for a while. So assuming you came across this repository, you don't know what the project is about, you don't know what has been done in it, the moment you see it, the first thing you want to do is to run the command git log, and it is going to give you the entire history of the repository. So let me minimize this a bit, and then we are going to inspect the history of this repo. So as you can see, the most recent commit is going to be listed first. Then it works its way all the way down to the earliest commit that was made in the repo. So the most recent commit was made by me. This is my email address. It was made on the 30th of May. And then the commit message is include note on continue statements. And then this is the commit SHA. All right. Then as you can see, this commit is pointed, the head is pointed to main, which is the branch of this, the branch on which this commit was made. We're going to talk about that. So if you know a little bit about shell, the display of the git log command comes with a less command. It displays it page by page, page by page. So you can use the arrow keys to scroll down, or you can use J or K to scroll up or down. Okay, so I'm just going to use the arrow key to scroll down, and as you can see, there are more commits in here. I can keep scrolling and scrolling and scrolling and scrolling all the way down to the very first commit that was made in this project. And as you can see, the very first commit I made in this project was made in 2022 September 11th. Okay, and this is the commit message that I supplied, and this is the commit SHA. So just with the command git log, we've been able to see the entire history of the project. So you go into GitHub, clone somebody's repository, and with git log you can tell what has been done in the repository from beginning to end. It's a really powerful command. Okay, but then there is a problem. What is the problem? What if there are 5,000 commits in a repository? Does it mean that you're going to run git log and you have to be scrolling through 5,000 commits in that repository? That is going to be too much work. So we have to have a means by which we can cut the scrolling, or be able to go to a certain specific commit that we are looking for. Okay, let's just go into my notes. Let me show you a few things. We're going to talk about the git show command very soon, but there is a command I want you to see right now, which is a command git log --1 line, and this command is used to cut out extra information. It displays only 7 characters of the SHA and the commit message. Okay, so let's go into my repo. Now, to quit out of this interface, just press the character Q and you come out of this git log interface. So let me clear my screen, and I'm going to run git log --1 line, not online, 1 line. Okay, now when I enter, see what happens. Instead of giving me all the details of the commit, the author of the commit, the full SHA of the commit, the date of the commit, and the commit message and everything, this command git log --1 line only gives you the first 7 characters of the SHA and the commit message. So it cuts out the scrolling for you. It makes it easy for you to know how the project has been, because it only gives you the commit message. You can easily go through the commits and see what the project has been about in the history of the project. Okay, so you can see that the very last commit in this project is this commit we have over here, which is the last 7 characters of this SHA. The commit message is include notes on continue statements. Then these are other commits that have been made in the project. Okay, in contrast to the git log command, you're going to have too much information, which is necessary though, but the --1 line flag cuts out all those extra information for you. Okay, so let me open a new terminal, and then I am going to run the command again, git log. Okay, and I'm going to have that side by side with the git log --1 line command. Wonderful. Why don't we change the color and make this one maybe blue or something? Wonderful. So the blue one you see over here is the output of the command git log. The green one is the output of the command git log --1 line. Okay, so the author, if you look at the very first commit, it has all this SHA with a git log output. You see A1C F6 blah blah blah. If you look at the 1 line, only the first 7 characters of this long SHA were brought, and the commit messages include note on continue statements. And as you can see, only the commit message was brought over here. Let's look at the second commit. It is a commit include note on break statements. As you can see, the 1 line, we have only the commit message, include notes on break statements, and the first 7 characters of the SHA. But over here in a git log command, we have more details: the author, the email, the date, and the commit message. So this is how you can use the git log command. Let's go forward and see how we can explore more git commands. Let us now use the git log --start command. This command is used to know which exact files have been changed. Okay, so over here you can see that we have the SHA and the commit message, but the question is, which exact files did I include a note on break statements on? All these commits that we are seeing in the git log command and then in the git log --1 line, we don't see which exact files have been edited. Let's say if I edited my HTML or CSS file, how do we know that these are the exact files that were edited? So in that case, if you want to know the exact files that were edited, the command to use is git log --start. So let's do that over here. I'm going to run git log --start. And as you can see, the interface has suddenly changed. We see the author of the commit. All right, we see the date, we see the commit statement message. Then in addition to that, we also see that the file that was edited is listed here. The file is in a directory C programming, and the name of the file is continue statement.md, and you can see that there were 35 insertions. So the -- start flag gives more information in addition to the git log command. And you can see files that were added, insertions that were made, deletions that were made. For instance, if I scroll down now, you can see that there are other commits in which there were deletions. For instance, with this particular commit, you can see that the commit message is improve markdown syntax. There were 70 insertions, and then there were 47 insertions, and then there were 23 deletions. Okay, so all in all 70 changes, and the file that was changed was patterns.md. So the git log -- start flag gives you more details in addition to the git log command. Isn't that wonderful? So we can see that, okay, so now we don't just see the commit message, the author and the date and all, we also see the files that have been edited. But the question is, what exact changes were made in the file? Okay, so I edited the markdown file, I edited this file, edited that file. What exact change was made in that file? You cannot tell with the git log -- start flag. So to know which exact change was made in the file, you need to add another flag, which is the -b flag. Okay, so let's go see it in my notes. So the git log -p, it says that we can see the actual changes that were made to a file. So let's go try it out. That's going to give us a lot of information though. So let me clear my screen. Let's try it out. Git log -p. The -p simply means patch. Okay, it simply means patch. So now look at this. Now we don't just see the commit message, we don't just see the files that were changed. Now we can actually see the changes that were made in the files themselves. This is the power of version control. So assuming I go into GitHub, I just pick any random project, I fork it and then clone it into my local system. I run git log and I can see every commit that has been made. Even if it's 5,000 commits, I'm going to see everything. And I run git log -- start, I can see all the files that they changed. And I run git log -p, that's patch, git log -p, and I can actually see the changes that have been made in a file from the beginning of the project to the very end of the project. Isn't this powerful? Very powerful. So now if I start scrolling down now, we are not going to finish, because you can see every change that has been made in a project from the beginning of the project to the very end of the project. We are going to see so many changes, and we cannot finish scrolling through today. So the question then is, assuming you are dealing with a project that has had 5,000 commits and you run git log -p, that means that you are going to have so much information. Is there a way to sample information? Let's say I don't want to read through everything, I just want to know a particular change that was made in a particular commit. Can I do that? Of course you can do that. Yes, you can do that. And the way to do that is to use the SHA of the commit to hone in into that particular commit. Does that make sense? Okay, so this is what I'm talking about. So we want to cut the scrolling now. Okay, we want to cut the scrolling. Instead of just running git log -p or git log start -- we are now going to add the SHA of a particular commit. So before we do that, let's now see that these are all the commits that we have in the project. Then now over here in the blue one, I'm just going to quit out of this interface. Let's say we want to see the particular change that happened with, let's say, solve second pattern commit, this particular commit. What do we do? Now the way to do it is to use the command git log -p, then you supply the SHA. Okay, so now this is the SHA. We want to know how the second parting was solved. So what you do is that you copy the SHA. First, you want to run git log -- one line so that you have all the commits listed and their SHAs. Then you can copy the SHA of the commit you want to inspect. So I'm going to copy this SHA and I'm going to come over here. I'm going to run git log -p and supply the SHA. And I enter. Now look at what happens. It's going to give me the information that I need concerning that particular SHA, that particular commit. So this is the information, this is the change that was made in this file when that particular commit was made. So it's like our chess game. We have gone back in time and we are playing the game exactly as it was from 3 p.m. or from 8 a.m. We can see the changes that were made. We can see how the project was at this particular time when the commit was made. Isn't that wonderful? So if I scroll through, you can see that this is the change that was made. It's a C code. You're seeing that this is the change that was made with that particular commit. But the interesting thing about this is that it cuts out the commits that are ahead and gives you that particular commit. However, everything that is beneath will be given to you. So assuming there is commit 1 to 20, and then you use the command git log -p, then you supply the SHA. Let's say you want to inspect the commit number 9. Okay, so it's going to give you commit number 9. It will cut out 1 to 8. Then it's going to start from commit number 9 all the way to the end of the project to commit number 20. So as you can see, we started from the commit SHA that I supplied, then the remaining commits just follow like that. But what if I want to see only one commit? I don't want to see the rest. Just give me the information of one particular commit, forget about the rest. And how do you do that? That is when you use the command git show. Git show. So I'm gonna clear my screen over here, and then let's say we want to find out what change was done when we solve the third pattern. Okay, so what you do is that you copy the SHA of that particular commit. So I'm just gonna copy that SHA, and then I'm gonna use the command git show. Then I'll supply the SHA. Okay, so I enter, and then you can see that this is the pattern that I was trying to solve with nested loops. Okay, don't worry about that if you don't understand it. But then in that particular commit, all the information and all the changes that I made in that commit are being supplied to me, and that is the end. So I don't get all the extra information of trying to scroll through. Only that particular commit information is brought to me when I use the command git show. Git show. Isn't that wonderful? Do you feel like your Git powers are growing? So let's go back. Instead of going for it, let's go back and recap everything that we have done so far. Okay, so we modify our files while we are in the working directory. Then we use the command git add to move our modified files to the staging index. Then we use the command git commit to move our files into the repository. And then every modification that is moved into the repository has a SHA, a unique SHA. So every image or every commit that is made has a unique SHA. So all these are commits that have been made in our repo. Okay, so now when you run git log, it gives you the entire history of the repository. But sometimes the history is a bit too much, so you want to reduce it to just the SHA and the commit message, and that is when you use the command git log -1 line. Okay, then sometimes you want to know which exact files have been modified in the history of the project, and that is when you use the command git log -start. Sometimes you want to see the exact changes that were made in the project and not just the files that were changed, and that is when you use the command git log -b. Sometimes the information is just too much. You're just scrolling and scrolling, and you want to just get the information of one particular commit, and that is when you use the command git show. Then you supply the SHA of the commit. So you bring the SHA of the commit. Then it gives you the information of that particular commit. This is basically all we've done so far. There is a lot more we have to learn, but so far this is what we have learned. Also, remember that we spoke about how to initialize this whole repository structure with the command git init. So the git init command is what initializes this whole tracking system. You get it? Okay. Then apart from using git init to initialize this tracking system locally, you can also clone a repository from GitHub. So to clone from GitHub, use the command git clone. Then you supply the link of the repo. That is the URL, the universal resource locator. Okay, so now that you understand this entire workflow, let us now change directory back into the one we started with. That's the git cause directory, and then let's do some wonderful things. I feel you are comfortable with the basics now, so let's start doing some intermediate things. Okay, lovely. So I'm inside my git cause repository now, so I'm just going to ls to see the files that we had in there. So we have the app.css file, and then we have the index.html file. So what we are going to do is that we are going to make some changes in these files, commit them, make changes, commit them, so that you get the entire flow. Then we are going to use that to learn about git branching. Okay, are you ready? Let's delve right into it. So this time around, let's use vi. Okay, so let's vi index.html file. As you can see, this is the content that we have in it, and that's the same content that we have here in our VS Code. It's the same content. We could have used VS Code, but I just want you to have an experience of both editors to know how to use them. Okay, so this time around, let's go into the insert mode by pressing the character I. We are in the insert mode now, so we're going to make changes to our HTML file. Okay, so what we're going to do is that let's try and link our style sheet. Like I always tell you, don't worry if you don't understand the code in here. Okay, we are just going to make changes. Your focus currently is version control and not what is going on here. Okay, so I'm just going to include my style sheet, and then we'll go and commit it. Then I'll make other changes and we'll commit it so that we create our own history. You get it? All right. So what I just did here is that I linked my style sheet in my HTML document. Okay, so I'm going to exit this interface, and I'm going to what? Git status. But now you have the command in your head. Okay, so you can see that it says that I modified index.html. But interestingly, I have another file here which is .vs code. This is not a file we created. It's just a VS Code configuration file that helps the file run in VS Code. So it's just a default file that VS Code has created on its own, so that it can help run the app that we are creating in VS Code. So don't worry about it. We are going to do something interesting with that file as well, and you are going to learn a lot with that, with the git ignore file. Okay, we'll come to that. We've not come to that yet. Now we have modified our index.html file. What did we do? We linked the style sheet. So if you are working on a real project, what would you do? You're not going to include many changes before you now come and say, let me make a commit with all those changes. No. Now that we have linked our style sheet, let's make a commit and then give it that commit message. Do you get the hang of it? All right, so we are going to git add our index.html file. When we get status, you can see that that has been moved to the staging index. You understand that now? And we are going to git commit with a message link style sheet, which is our CSS file. And we enter. We have made a commit. Okay, now let's create another file, which is a JavaScript file. All right, and then we'll put in some code. Okay, so let's create a file. Let's call it app.js. because it's a JavaScript file, right? So I create this file. Let's say we want to create a function that listens to a button click. Okay, so let's just put that code in here. Okay, so I just created a function that handles a button click. You don't have to understand this code, but what I'm going to do is that I'll create a resource folder, and I'll put all this code inside so that you can follow along as we go. So you just go copy this code and then come and paste it in your JavaScript file which you just created, so that you can just follow the tutorial. All right, so I'm just going to exit this interface, and then what am I going to do? I'm going to get status. You got it now. Now you can see that I just created a new file, app.js. So let's make a commit. Let me clear my screen and let's make a commit. I'll magnify this a bit. So we are going to add our file, app.js. Now when we get status again, you see that our app.js has been moved to the staging index. All right, but our .vs code is still in a working directory. That makes sense? All right, so we are going to make a commit. Let me clear my screen. So git commit with a message. What will be our message? We are going to use the exact message in the function, okay, so that anyone who reads the commit message can know what this commit is doing. This is how you make commits. All right, so we are going to say add function that handles a button click. Exactly what we did. All right, now I've made a commit. All right, now let's just go into our HTML file and then effect the corresponding change in the HTML file that we just did in a JavaScript file. Okay, this time around I'm going to use VS Code so that it looks colorful for you a bit. Okay, so this is our app.js file which we just created, and this is the code inside it. All right, so we are going to effect the corresponding change in our HTML file. So the first thing we want to do is to link our JavaScript file to our HTML document. So we are going to use a script element. So our script, and then our source is our app.js file. Okay, now let's go make a commit. Okay, so when we run git status, you can see that we have modified our index.html file. What did we do? We linked our JavaScript file. So let's do it. Git add index.html, git status, it has been moved to the staging index. Then git commit -m. What did we do? Link JS file in HTML doc. We have made another commit. We are going to keep going. So the function that we created that handles the button click, let's go create that button in the HTML document. I always tell you, you don't have to understand what is going on yet. You will. It's just a matter of time. So just copy and paste. Our focus today is version control. Sometime in the future, we're going to come to all this. For now, just keep copying and pasting. Make your commit, copy and paste, make your commit. All right. Then we are going to run our git log and see how it looks like. Okay. So let's go into our HTML file. And then inside the body, let's create an input element and a button. Okay. So I got it here. Then I use the ID my button. That's what we use in the JavaScript file. Okay, so let's go into our terminal and run git status. I tell you, you're going to run this command a million times. Okay, so we've modified our index.html file. What exactly did we do? So we are going to git add. You know what? Before we do that, let me teach you a certain command. So I'm going to clear my screen. Let's say somebody was working on a project and then you were asked to take over. When you take over, you are definitely going to run git status to know the current state of the project. But when you run git status, it's going to tell you the files that have been modified. But certain files would have been modified and the developer might not have made a commit yet. So how would you know the exact changes that have been made and yet have not been committed yet? There is a command that you use for that, and that command is git diff. Git diff. Okay, so let's git diff and see what happens. So I just git diff, and you can see that git diff is telling me that a change has been made in index.html. This is the first version, this is the second version. All right, and don't worry about all these. It's just telling you that some insertions have been made in the second file, and the first one some deletions have been made. Okay. Now you can see that inside my head, inside my body element, these are the changes that I just made. I added an input element and I added a button element in my HTML file. However, I have not committed these changes yet. So before you make a commit, if you want to see the changes that are in your working directory, the command that you use is what? Git diff. Okay, so let's go on. Now we're going to clear our screen and get status again. So we have modified our index.html file. So let's git add our index.html file, and then we are going to git commit with a message. What is our message going to be? It's going to be create button and input element. We just made a commit. Wonderful. Are you loving it? So now let's run our git log and see how our project looks like now. So git log, bam, and you can see this is the last commit that we just made. Create button and input element. Then this is a commit that was before that, link JS file, and this is a commit that was before that, link style sheet, add CSS file. Then this is the initial commit that we made, initial commit. So you see our log is beginning to take shape. Okay, our log is beginning to take shape. Okay, so let's get out of here. And then let's run the command git log -- one line. You know what this is gonna do, right? So you see that this one is just gonna give us the 7-character SHA and then the commit message. So these are the commits that we have made in our project so far. Okay, now if you look at this carefully, you're going to realize that all my commit messages have a certain pattern. I didn't say that I added a CSS file, or I linked a style sheet in the past tense, or I added a function that handles button, or I linked. I'm doing it in the imperative format, and there's a reason why I'm doing that. Your commit messages must have a certain format so that your commit messages will look very clean. If anyone picks your project and runs through the log of your project, your commit messages must be neat. It's very important as a developer. So whenever I'm writing commit messages, I make sure I write it in the imperative format. It's like I'm giving you a command. That is how you should write your commit messages. Don't write it in the past tense that I did this. No, do it in the imperative format. It's like you are giving a person a command. So whenever someone is reading your commit message, it should be like, this commit does so and so. So in this commit, I add CSS file. In this commit, I add function that handles whatever. In this commit, I link a GSS file. So whenever you're about to make a commit in your head, say in this commit, I then bring the commit message. That is how I should read. So let me go into my notebook and then let me show you a few things. Let me give you a few secrets on how to make very good commit messages. Okay. Now, when should you make a commit? Each commit must have a single focus. To realize that I didn't link my style sheet and then link my JS sheet and then create a button all in one commit. No, don't do that. I linked my style sheet, that's a commit. I linked my JS sheet, that's a commit. I created a button, that's a commit. Okay, I added a function that listens to a button click, and that's a commit. This is how you should arrange your commit. So your commit should have a single focus. Okay, your commit shouldn't include unrelated changes. You already know that now. Think, what if all the changes in this commit were erased? Now, the reason why you have to make your commit very specific is because something could happen in a project and your senior developer wants to erase a certain commit. Now, if you included so many changes, unrelated changes in that commit, now when that commit is removed, everything is going to be lost along with it. But maybe he just wanted to make a little change. So it is important to make your commit very specific. I need you to listen to this. Are you with me? Okay, so now what makes a good commit? Keep the message short. You can't make a commit and then you're like writing an essay. The good thing is that the commit message is just the title. If you want to include extra information, you can actually do that. Okay, so in our terminal, just in case, let's go make a change in our HTML document or any of our files. We're going to make a commit and I'll teach you how to add extra information to that commit. Are you with me? Okay, so I'm going to go into my HTML file and make any random change. So let's say in my body, I add a paragraph. So let me add a paragraph in there. then I will say this is a paragraph. Do you see it? I just added a paragraph. So let's say I'm adding a paragraph on why you must know Git. Okay, so let me say why you must know Git. Now I just added this paragraph. All right, so I'm saving my document. I'm gonna go into my terminal. Before I make a commit, let me use the command I just taught you, which is git diff. Now look at what happens. It tells me that these are the current changes that have been made in the document that have not been committed yet. All right, now when I get status, it tells me that I have modified my index.html file. So we're about to make a commit, but however, this time around, we are going to add extra information to the commit. Okay, so we are going to get commit -m with our message. Then the title of our commit is going to be, let's say, add info on Git knowledge. Very short commit. Now, if you want to add extra information to the commit, you use a second flag, another -m. Get it? So we are going to -m again. So we have done our first commit title. Now we're going to add extra information to the commit. So we are using two -m flags. That is how you add extra information to your commit. So now with the second message, you can take your time and elaborate, explain. You can take your time and explain what this commit is going to do, just in case you need to explain. That is how you do it. It's very simple. Okay, so now this time around, this is going to be an elaborate explanation of your commit. Okay, get it? So put it in quotation marks. I didn't bring my first quotation marks, sorry. Now I just realized that I didn't add before I committed. Okay, so we have to get add first before we commit. So we needed to do that. So we get add our index.html file. Now let's get status again. Wonderful. So now we can get commit. Let me clear my screen. So get commit -m. Then our first message. Now our second message in quotation marks. Okay, now we enter. So we can now run the git log of the project and see how it looks like. Now this is a commit message that we just made. Look at it very carefully. This is the author, of course. This is the email, this is the date, blah blah blah. Add info on Git knowledge is the title of our commit. And then it says that this is an elaborate explanation of your commit message. So that's the extra information that we provided for the commit. So you can actually make a commit, give the title of the commit, then have extra information about the commit with a second -m flag. That is very important. Okay, now when we run git log -- one line, then we only have the commit title. These are our commits so far. Are you learning something? Now, assuming you wanted to know the exact information that went into this commit, what you do is you copy the SHA. I click my screen. Then you get show and supply the SHA and enter. As you can see, it says that this is a commit message, this is a commit title. And when we begin to scroll down, it gives us the exact information that went into the commit. This is the power of version control. Now that you understand this, let me just clear my screen. And then let's talk about what is known as a git ignore file. Git ignore file. Now this is a very important file that you are going to need in your version control system. And that is because there are certain files that you won't need Git to track. Maybe there are software download files, maybe there are configuration files, maybe there are package files. You don't want Git to commit these changes. You don't want Git to add it to your commit, and yet you want it to be in the structure of the project. What do? How do you make Git ignore such files? You use what is known as a git ignore file. How do we do that? Now let's go into my notebook and then read a little about what git ignore files are. Now take note that there's a period. Okay, there is a period at the beginning of the git ignore file. It is a file that tells Git which files or directories to ignore when you make a commit. All right. This file should be placed in the same directory that the .git directory is in. Remember that when we initialized our repository, there was a hidden folder or directory known as .git. If you want to create a .git ignore file, you have to place that file in the same directory that a .git directory is in. We're going to see that right now. It is used to tell Git about the files that Git should not track. You get it? Now let's go into my terminal and then let's ls. This time around we are ls with a flag -a so that we can see the hidden files. All right, you can see that this hidden file over here, the .git file, is a file system that is being used to track our project with version control right now. Okay, now we are going to create another file called a .git ignore file. Okay, so let's create that file with the command touch and then git ignore. The reason why we are putting the dot ahead of it is that it's going to be a hidden file. Remember what I told you? Folders or directories and files with a period ahead of them are hidden files. You get it? Now I've created a git ignore file. Now when I ls, you're gonna see that these are the files that we have in our system that can be seen. But when I ls-a, you can see all the hidden files here. And now the .git ignore file is part of our hidden files. Awesome. Let me clear my screen and I'm going to git status. Like I told you, we have this .vs code file over here which we don't want Git to track because they are just package files that is helping VS Code to be able to run our HTML file, but we don't need Git to track that. So what we can do is that to make Git not track any directory or a file, you just have to place it inside the .git ignore file, just the name of the file. So let's do that. Now we're going to enter this file. Let's do that in VS Code. So you can see that our .git ignore file is now here. All right, now let's go into that file and then let's say we don't want to track this .vs code directory. Okay, so I'm just gonna copy that and I'm gonna put it here and I'll save my file and close it. Now I've come to run git status here again and you're going to see what happens. So git status, suddenly you can see that that .vs code directory is no more being tracked. Initially when I ran git status, you could see it in a system. So the .vs code file was here initially when I ran git status, but now I put the name of that file in the .git ignore file and suddenly it's no more being tracked by Git. Okay, so let's understand it very well. Let's create another file. Let's call it, let's say Leo dot, let's touch Leo dot, let's maybe create a Microsoft Word file. So let's call it a document file. Okay, now when I get status, you can see that I just created a file Leo, which is a document file. All right, now I don't want Git to track this file, so what do? I have to place the name of this file in my .git ignore file. So let's come into the .git ignore file and then add another name. So we just created Leo, which is a Word document. I've added that. Now I'm going to save my file, then I'm going to get out of here. Now when I go into my terminal and run git status, now that file is no more being tracked. This is the power of the .git ignore file. Very powerful. However, you need to take note that Git itself is tracking the .git ignore file. Does that make sense? The .git ignore file must be pushed to your GitHub, but then their content will not be tracked by Git. Yet that .git ignore file itself is being tracked by Git, so you can see that it's in a working directory. So let's git commit. No, let's git add first. Let's get status. Now we have moved our .git ignore file into our staging index. You get it? Now let's commit, git commit with a message. We add the .git ignore file. Close our quotation marks and enter. Let's git log -- one line. You can see that now this is our most recent commit. Add git ignore file. Are you learning something? Now the next thing we are going to do is very important, so I want you to be paying attention. Okay, we're going to talk about globbing, but not yet. Assuming you want to move several files into the .git ignore file, and now are you going to name all those files? Assuming there are a certain number of files, like 1,000 files, and you don't want Git to track them, does it mean that you are going to put those files, the name of those files, one by one into your .git ignore file? No, you don't have to do that. There is something called globbing that helps you match the character. Let's say you don't want Git to track all the files with an extension JPEG. So you can glob it, and then Git is not going to track all those files with that extension. We'll talk about globbing, but let's talk about something more important first, which is Git branching. Now, what is a branch in Git? A branch is the structure on which your commits are made. Whenever you make a commit, those commits are being made on a specific branch. Okay, so you are always on a branch. In a Git system, you are always on a branch. When a commit is made, it is added to the branch, and the branch pointer points to it. We are going to understand what that means. Okay, then if you look into our command line, there's something that we have been ignoring and not talking about all this while. This is the time for us to talk about it now. The head points to the active branch. You can use the checkout command to switch which branch it is pointing to. Let's visualize this and see what we're talking about. Before we do that, let me show you something in the command line. Whenever we run our git log -- one line command, you are always seeing that there is this head over here which is pointed to something called master. This is because all this while we have been working on the master branch. When we have not created any other branch, we've only been on the master branch. So all this while the head has been pointed to the master branch, which means that we are working actively on the master branch. Do you get it? Now I'm going to clear this screen. Then I'm going to show you something. Whenever you want to see the branches that are in your Git system, the command you use is git branch. Git branch. And as you can see, we only have one branch in our Git system, which is the master branch. And then this asterisk you see over here indicates that that is the active branch that we are working on. Now let's visualize this and see what we mean. So now as you can see, we are on the main branch. The main branch many times is also known as the master branch. You can always change the name, but then the de facto or the default name that is given to the main branch you have when you start your project is either the master branch or the main branch. When you clone it from GitHub, the name is main. When you initialize it from your local system, the name is master, but they are one and the same thing. All right. So over here, we are going to make a few commits just for you to see how the Git system works. All right. Now I'm going to git commit, and as you can see, I just made a commit, and then the branch moves forward. It's like the branch is growing. The branch is growing in our commit. Do you get it? Now we're going to make another commit. We are growing the branch, but currently we are on the main branch or the master branch. Do you understand? Okay, let me magnify this a bit so that we see clearly. So I'm going to make another commit. As you can see, now we are on commit 4. Okay, we are on commit 4 and our branch is growing. This is the main branch, or this is the master branch. How do we create other branches, and what is the purpose of branches? Let's say I'm working on my project. Okay, now I want to effect a certain change, but I don't want this change to be on the main branch because I'm not so sure of the change yet. Later on, I'm going to incorporate this change into the project structure, but I do not want the change to be effected on the master branch yet. Okay, so now I'm going to create another branch, and I'm going to experiment with that branch, see how the changes look like, and then when I'm done, I can merge it to the main branch. Now the advantages of branches in Git is that you can always switch to a branch and switch to another branch. However, whatever branch you are on, that is a branch that will have the active project structure. If you don't understand what that means yet, keep listening. Okay, so we have made about 4 commits right now. We are on commit 4. So what I'm going to do is that I'm going to create a new branch. Okay, then we are going to see what happens. Let's say in my HTML document, I want to add a footer. All right, I want to add a footer element, but I don't want to effect this change on the main branch. Okay, so what we are going to do is that you can create a new branch, and one thing I keep saying is that give your branches descriptive names. The last time I was teaching on functions, I said that give your functions descriptive names, give your variables descriptive names. That's because in the future, when you are working on a very convoluted project structure, you're not always going to remember the code that you wrote and what it does necessarily, but it is these descriptive names that will remind you that, oh, this is what I was doing, or that is what I was doing. It is very important to give your project descriptive names. Okay, so I'm going to create a branch that adds a footer to the HTML element, and guess what I'm going to call the branch? Footer. You get it? Okay, so the command to create a branch is git branch. Then you bring the branch name. All right, the branch I'm creating is footer. Then I enter. Now see what happens. We have a main branch. It is active because I told you that the active branch has an asterisk by it. Okay, now we have created a footer branch, however we have not switched to it. That is not the active branch. Okay, so assuming I make a commit right now, git commit, realize that it is the main branch that has moved. The footer branch is still pointing to the commit form. Okay, now I'm going to make another commit on the main branch, git commit. As you can see, because the main branch is the active branch, that is the branch that is moving. You get it? Now, so that means that if I switch to the footer branch right now, all the changes that are on the main branch are going to disappear in the project structure. You're not going to view it. We'll see the practicalities of it in a bit. But however, just follow the scenario that I'm showing you here right now. Okay? Now, we are going to switch to the footer branch, and then we are going to make a commit, and then you see what happens. So the command to switch to another branch is git checkout. Then you bring the name of the branch. So we are switching to the footer branch. Okay? Now when I enter, see what happens. The asterisk has moved from the main to the footer branch, which means that now the active branch is the footer branch. Now this simply means that all the commits that we have made on the main branch, which is C5 and C6, will disappear in the project structure. It doesn't mean that it's deleted. It's there. It's on the main branch. Just that it's another branch that we have created. Do you get it? Now I'm going to make a commit on the footer branch, and let's see what happens. So git commit. Now you see I have created two branches now. I've made some commits on the main branch, and I'm making some commits on the footer branch now. Let's make a few more commits on the footer branch. So now we have commit 8. Let's make one more commit. So you see, every change that is occurring on the footer branch is not on the main branch. So when I switch to the main branch right now, all the changes that I've made on the footer branch are not going to appear in the project structure. If I want to see those changes, I can move to the footer branch. But then the good thing is that you can always merge branches so that the changes that are in both structures are going to appear. So now to do that, you first of all have to check out. That means that you change the branch to the main branch. So I'm checking out to main. Right now you can see that the asterisk has moved to main, which means that that is the active branch currently. All right, then I am going to merge the main branch, the footer branch, into the main branch. Whenever you are going to merge branches, make sure you are on the main branch. That is the main branch. That's the master branch. Then you merge the other branches into the main branch. Does that make sense? Okay, so we are going to merge with the command git merge. So you can see that the asterisk is on the main branch, so we can now merge another branch into it. So let's try merging that and see what happens. So we are going to git merge. We are merging which branch? We are merging the footer branch into it. Okay, then we merge. See what happens. Now the changes on the footer branch has been incorporated into the main branch, and when you go upstream, when you go up the branch, you can now you have two parent branches in the stream. So you have the main branch and you have the footer branch, which are all parents of commit number 10. So if you make another commit, you realize that now the branch is just going to continue, and the main branch is the active branch currently. It's just going to continue this way. This is what Git branching is about. There's a lot more we are going to learn on Git branching, but I just wanted you to see the illustration of this so that you have an idea of what we're about to talk about. Okay, now that I have incorporated all the changes of the footer branch into the main branch, and I can safely delete the footer branch, and I don't lose the structure or the changes that I made when I was on the footer branch. Okay, so you can just git branch -d. Then I bring, that's it, I want to delete one branch, and I delete the footer branch, and I enter. As you can see now, the footer branch is gone. Everything is in the main structure. This is one way by which we can do it. So let's go into the practicalities of it. Let's go into our command line. Let's create another branch and then make changes on our HTML in our HTML document and see how everything works together. Okay, wonderful. So as you can see, I'm currently on the master branch because that's the active branch we see in our system. And the way in which I've configured my Git, whatever branch I am on shows up in my Git structure. Later on, I'm going to teach you how to do this. It's a Git configuration so that whatever branch you are on shows by your username. Okay, we'll talk about that later. Just remind me. Okay, just remind me. All right, so let's create another branch and let's call it footer. So we are going to git branch. We are going to call it footer, just like we did in the illustration. All right, so I'm going to enter. But as you can see, it's still the master branch that is active. That is because we have not switched. Okay, we have not switched to the footer branch. If you want to be on the footer branch, we need to switch. All right, so I'm going to git branch to see the active branches that we have in our system. Git branch, and I enter. You can see that now we have the footer branch listed in our branching system. We have created a new branch, but that is not the active branch. If you want to switch to it, then we need to git checkout the name of the branch, which is footer, and I enter. So as you can see, it's telling me that I have switched to branch footer. If I git branch again, it tells me that the active branch is now footer. You see the asterisk by the footer branch. This is how the branching system works. So now what's going to happen now is that whatever change I add now is going to be on the footer branch. It will not be on the master branch. So let's add some changes to my HTML document and then we'll see how the project looks like. Okay, before we do that, let's see how our project looks like right now. This is a HTML document that we've been working on, and this is how it looks like. It doesn't look very good currently, but I believe by the time we are done, we'll have a very beautiful page. Okay, so this is how our project is looking like right now, and we are going to make some changes to it on the footer branch. Now take note that we are now on the footer branch. The active branch is footer. Let me just clear my screen. We are on the footer branch. Keep it in your mind. We are on which branch? We are on the footer branch. So all our changes will be made on the footer branch, not on the main branch. Okay, I need that to be ingrained in your mind. That is why I keep repeating it. Okay, we are on which branch? We are on the footer branch. Stay with me. Okay, all right. Now let's go into our HTML document, and I'm going to add a footer to our project structure. We're gonna do it inside the body. And let me say something like Leo's website. Okay, lovely. All rights reserved. Lovely. So I have added a footer tag to our HTML element. Okay, now let me save that, and I'm going to go into my terminal. I'm going to git diff. You understand this command now, and as you can see, the chain that we have added to our project structure is the footer element, and with some code inside it, with a paragraph element inside it. Okay, so now let's clear the screen. We are going to commit this change while we are on the footer branch. Okay, so we are going to git add. Let's get starters first to see what we have. We only modified index.html with a footer tag. Now we are going to git add. If we get starters again, we see that we have added it to the staging index. So let me clear my screen and git commit with a message. What do you think our message will be? You can leave what you thought the best commit message would have been in the comment section below. All right, so we are going to commit with a message add footer. All right, lovely. Now when we get starters again, our branch is clean. There is nothing to add. Now I'm going to go into my graphic user interface and refresh the page to see if our footer tag has been added. So I'm just going to refresh the page, and as you can see, our footer has been added. Copyright 2023, Leo's website, all rights reserved. Our footer has been added. Now what I'm going to do is that I'm going to switch to the main branch, then I'll refresh the page again and you see what happens. So I'm on the footer branch now. I'm going to get checkout main. Okay, what went on? Let's see the branches that we have. So git branch is master, not main. That is why we had that error. So we are gonna git checkout master. Now I have switched to branch master. Okay, so I'm gonna go into my project structure and refresh again. And as you can see, suddenly the footer is gone. Why? That's because the change that we made that change on the footer branch. So the moment I switch to the master branch, it's as if that change was never made, because that change is not in the project structure of the master branch. That change is in the project structure of the footer branch. That is why when I switch to the master branch, that change is gone. So I'm going to clear my screen and switch again, git checkout to the footer branch. I've switched to footer. Now I'm going to refresh my page again and let's see what happens. The footer branch is back. You can see all rights reserved, news website. Let's add a little style. Okay, let's add a little style to the footer so that it looks a little appealing. All right, we can even put it in a div element so that it looks a little appealing. Then we are going to refresh the page again and see how it looks like. We'll commit that change still on the footer branch. Okay, so let's stay on the footer branch. We are still on the footer branch, and then let's go into our HTML document. Now let's put this in a div, and then let's just go into our CSS file. This is actually h1, right? So in our index.html, it should be h1. Okay, we'll come and make that correction. All right, so in our CSS, let's add a little style to our footer. Lovely. So I just added a background color white. All right, I can change the color. All right, for now let it be white. Then I added a padding, I added the text align. I want the text to be centered. All right, lovely. Now that I've added a change to my CSS file, let's go and make that commit in our command line. So we're gonna git diff. We want to see the change that we made. We added the styling to our footer branch. Lovely. Now, and then we also added a div. We put it in a div. Lovely. So let's git add, let's git status. We modified app.css with the styling, and in the HTML we put it in a div. All right, ideally it's best to make all these different commits. Okay, but we are in a tutorial, so let's just go. Okay, now we are going to git commit and we'll say the message is style footer. You get it? Now I'm gonna enter. So let's go into our graphic user interface and refresh and see how it looks like now. Lovely. So as you can see, we have added a little style to our footer element. But take note that if I switch to the master branch, all these changes are not going to be seen. Okay, I'm going to switch to the master branch now and make another change on the master branch. Realize that when I switch to the footer branch, that change is not going to appear. So I'm going to git checkout master. Now we are on master. Realize that if I come here and refresh, this change is gonna go away because that change is on the footer branch. Just keep following. I need you to keep following. Now let's go into our HTML document and then make this correction. This is supposed to be, our header is h1. Okay, so h1, and in our CSS we are saying that we should color this as red. Okay, now let's save this and go and commit it in our command line. So git add, git status. Our file has been moved to the staging index. We're gonna git commit with the message style h1 element. Lovely. So let's go refresh and see how our project looks like now. You see, it's looking a little different, but the footer element is not here because it's on the footer branch. Now I'm going to switch to the footer branch. You're going to realize that this change is also going to disappear. So let me git checkout footer and I enter. When I come and refresh my project, I realize that we have gone back to the change as it was on the footer branch. But when I switch to master, git checkout master, and I come and refresh my project, then the changes that we made on the master branch is what's going to appear. We are making progress with our page. Okay, now what if the change that we made on the footer branch, we now want to merge those changes with the one we made on the master branch? That is when branch merging comes in. Branch merging. Okay. So let's go into we'll talk about the head a bit more. Okay, let's go into my name and then just talk about branch merging a bit. We'll also come to these. In branch merging, we have what is known as the regular merge and we have the fast forward merge. The regular merge is what I showed you in our illustration over here. So the regular merge has commits on this branch, it has commits on this other branch, then they are merged together. But the fast forward merge just brings the branch forward to the current commit. I'm going to show you. Just don't worry, I'm just going to show you. So as you can see, we are on the main branch now. So let me create a branch and then switch to it and then make a few branches on that commit so that I explain to you what the fast forward merge means. Okay, now, so I'm currently on the main branch. I'm going to create a new branch, git checkout -b. The name of the branch I want to create is footer. Now you see that what I've done currently is different from what I've been teaching you. I told you that if you want to create a new branch, use git branch, then the name of the branch. If you want to switch to the branch, then you use git checkout, then the name of the branch. But you can also create a branch and switch to it at the same time with the command git checkout -b. Then you bring the name of the branch you want to create. That is what I've done over here. So git checkout -b. The branch I want to create is footer. So I just enter. And as you can see, I've created a new branch footer and I'll switch to it at the same time because the asterisk is right by the footer branch. I'm going to make some commits on the footer branch. So git commit, git commit, git commit, git commit. So as you can see, we have left the main branch way behind. From the point when we started branching on the footer branch, which is commit number 1, we left the main branch at commit number 1 and we have moved all the way to commit number 5. So the main branch has been left behind. We have left him behind. Okay, so we are going to merge these two branches and then we are going to see what happens. So in order to merge a branch, I told you that be on the main branch, and you merge into it. So the branch that you are trying to merge into is the one you have to be on. So before I merge, I can't merge while I'm on the footer branch because I'm merging footer into main. Main is a master. You get it? So I'm going to git checkout to main. Get it? Now I'm on the main branch. You can see the asterisk. Okay, then I'm going to git merge footer because I want to merge footer into main. Alright, then I enter. See what happens. This is what is known as a fast forward merge. Because when we branched into the footer branch, we didn't make any new commit on the main branch. It was just left behind. So when we git merged, the main branch was just moved forward. It was a fast forward merge. And if you look over here, you can see that fast forwarding. It says fast forwarding. It was just a fast forward merge. But the earlier one that I illustrated to you is what is known as the regular merge. There are commits on this branch, there are commits on this branch, and those commits are put together. So when you go back into history, you are going to see two parent branches. You love it? So let's go back into our projects that our front-end projects that we are trying to create. And now I'm going to show you a certain command. If you want to see the entire log of the history, I've already shown you git log --1 line. It shows you the entire log of the history with a SHA and a commit message. But what if you want to see the entire history with the branches? For instance, right now, if I run git log --1 line, it is showing me all the commits only on the master branch. But we know that in this project structure, we have another branch called the footer branch. But it's not showing me the footer branch. It's only showing me the history of the master branch. What if you want to see all the history in the entire project system, the entire project structure, all the branches that have ever been in the project structure? What command do we use? The command that we use is git log --1 line --decorate --graph. Now we want the history in the graph system. Okay, not just in the graph system, but we also want all of it. --all. Now enter. Do you see what I see? This is the initial commit that we make, and it works its way all the way up to the top. You can see that we made a few commits, and at commit 3C56CAE, we branched. So we created a new branch at this point, and then we made a few commits on the footer branch. So we added a footer, we styled the footer while we were on the footer branch. So you can see the footer branch over here. Then we switched to the master branch, and on the master branch we styled the h1 element. So you can see the entire history with the command git log -- one line -- decorate -- graph -- all. Very powerful command. Write it down, jot it down, jot it down. This is the command, jot it down. Very important. You need it. You need this command. Okay, but as you can see, the active branch is currently the master branch. That is because the head is pointed to the master. The head is pointed to the active branch. The head is always pointed to the active branch. Now, if we switch to our footer branch, so git checkout footer. Now you can see we are on the footer branch. Let me clear my screen. If I run the same command, git log -- one line -- decorate -- graph -- all, and I enter, you can see that now the head is pointed to the footer because that is the active branch. Get it? I'm going to switch again to the main branch, git checkout master. Get it? Then now I'm going to git merge. Git merge footer. Do you see what's happening here? Because I've configured my VS Code to work with my Git, it automatically opened my code editor and it's waiting for me to supply a commit message. But it has given me a default one, merge branch footer. I can choose to use this or I can change it, but I think it's a good one. It makes sense. It's descriptive enough. So let's use it. Okay, so we are going to merge the branch footer. Since it has supplied a commit message for us, all we are going to do is we are going to save, exit the code editor. Okay, so you can see that in our command line, it's telling us that additions and deletions have been made in our app.css file, and in our HTML file there are 7 changes in all. 2 files change. The files are app.css and index.html in our merge. Let's run the command git log -- one line -- decorate -- graph -- all. Now look at what happens. When you do a regular merge, a commit message is created for that merge. An entirely new commit, which is commit 3884, that's the shell of the commit, and the head is now pointed to master. Merge branch footer, that's a commit message. Let me minimize this and make you see it well. Lovely. So the commit message, the current commit message is merge branch footer, and a new commit, an entirely new commit has been created for that merge. But for the fast forward branch, for the fast forward merge, no new commit was created. We were on commit number 5. Then when we merged it, the main branch was just fast forwarded to the current commit. But that is not how the regular merge works. With the regular merge, an entirely new commit is created for the merge. So let's see that we are currently on the main branch. Let's make a commit there. Git commit on main, git commit. Then I'm going to switch to footer, git checkout footer. Then I'm going to make a commit. I'm going to make a commit. I'm going to make another commit. So there are commits here and there are commits there. I'm going to merge and you see what happens. So I'm going to switch to master, git checkout main. Now I'm on the main branch. Now I'm going to git merge footer. See what happens. An entirely new commit number 11 has been created, and the head is pointed to commit number 11. So if I add a new commit again, you realize that it branches out from it. Now we have commit number 12, and the head is pointed to commit number 12. Do you understand what's going on here? So this is a regular merge. An entirely new commit is created for the merge, and that is what we see over here. So this is a merge commit. Now when we go into our project structure, we're going to realize that when we refresh it, everything is now showing. The footer that we styled, the header that we styled, everything is now showing in the project structure. This is Git branching in simple terms. So now that you know what branching in Git is, let's talk about something very important known as merge conflict. Merge conflict. This is so essential. You are definitely going to come across it in your software engineering journey. So you need to pay a lot of attention here. Okay, let's see the current state of our project. It doesn't look very saucy right now. So let me throw in a few elements here and there. Let's just bring it to life a bit. Then we are going to engineer what is known as a merge conflict. Okay, so the first thing, let's, instead of a Git course, let's change it to a personal profile. So let me change this to my personal profile. Okay, so in our HTML element, now let's commit that. So I've just changed the header. Let's also add a navigation bar. Okay, let's make the page come alive a bit. Great, so now it's my personal profile. Let's add a navigation bar. Let's refresh and see how it looks like. Okay, so I have some about, skills, portfolio, and contact here. It looks good. Now let's commit that change. Awesome. Now let's add an about me section. Okay, let's go into my HTML file. Let's see if we can add an about me section. Let's put it right here. Let me comment that about me. Let's see how that looks like. Okay, our page is coming alive. Let's commit that change. Lovely. What else can we add? Let's add some skills that I possess. Okay, let's try to make the page alive a bit. Let me clear my screen. Let's go into my HTML. Let's see how that looks. Okay, that's cool. Let's commit that. That looks cool. Let's see if we can add a portfolio section. Comment that portfolio. That looks okay. Let me refresh this and see what I get. Lovely. My page is coming alive. Let me link another image and see what we get. Okay, our page has come alive a little bit. All right, let's commit the changes that we made. Awesome. Now let's git log -- one line and see the commits that we have. Wonderful. So remember that we have left the footer branch behind, okay, but we merged it into master, so that is not a problem. Then I changed my header. I added a navigation bar, I added an about me section, I added a skills section, and now I've added a portfolio section. That is what I've added so far while you were sleeping. Okay, so all this was done while I was on the master branch. Now I'm about to create another branch, okay, and I'm going to create it at a certain point. You're going to see that. Then I'm going to make a commit that contradicts another commit. Then I'll try and push that, and you see what happens. This is what is known as a merge conflict. So as you can see, this commit over here 575DC9C, this commit over here is when I changed the header. Okay, so assuming you wanted to see what exactly happened with this commit, so I'm just gonna copy it. Let me clear my screen. So I'm gonna git show, and I supplied the SHA of the commit. So you can see that with that particular commit, I changed the header from git course updated to my personal profile. You see that? Awesome. So I'm just gonna clear my screen and run the command git log -- one line one more time, and you can see that commit over here. This is where I changed the header. Okay, I'm going to create a branch, and this time around I'm not gonna create it exactly where the current commit is. I'm going to create it behind. Now let me illustrate that to you. So assuming we make a commit, git commit. Now if I create a branch right now, it's going to be created at the exact point where the current commit is. For instance, I get branch, and then let's create a branch called footer, and I create this branch. It has created a branch at the point where the current commit is. But sometimes you can go back in history and then create a branch from a certain point. What you need to do is to point the head at that commit, and you do it with the SHA. So let's say I want to create a branch at commit number 1. Okay, so now what I need to do is to get branch. Let's say I want to call the branch Leo. Okay, I'm creating a branch called Leo, but I'm creating it at the point where commit number 1 is. So I enter the SHA of that commit and I enter. See what happens. Now a branch is created at the exact point where we wanted that branch to be created. So when we check out to that branch, let's say get checkout to Leo, and I make a commit, get commit, the branch starts from that point where we indicated. Do you get it? If I make another commit, it just continues from there, that point forward. So you can go back in time and then work on a certain point of the project. This is what I've been trying to tell you from the beginning of this course, that the chess pictures that we took, we can always go back and play the game from any of that point. We can arrange the pieces on the board from the way it was at any point in time, and we can play it from that point forward. This is what I've been trying to tell you all this while. So at the current state of the project, when we made commit 1, we can go back in time, we can create a branch and switch to that particular commit. Everything that we had done from C2, C3, C4, everything will not be visible in the project structure. So when we start making commits from C5 and C6 downward, that means that we have come back to the state of the project when we made commit 1, and then we are changing the branch. So we are now making commit 5 and commit 6. So C2, C3, C4 all have disappeared in the project structure. We went back in time and worked from that point forward. Does it make sense to you? So that is what we are trying to do over here. We are going to create a merge conflict. So I'm going to go back in time to the point when we change our header. So let me come to this commit, merge branch footer. Okay, before that, let's just clear my screen and run the git log dash one line dash decorate dash graph dash all, so that we see the point that we want to create the branch from. Okay, so let's clear this out. Let's run git log. Wonderful. So we are going to create a branch at this particular SHA. Okay, so I'm just going to copy the SHA. Then I'm going to create a branch, get branch. Because we are going to create a merge conflict, let me call it a merge conflict. So let's call this branch merge conflict. Let your branch be descriptive. Okay, then I supply the SHA. You get it? All right, then I enter. Let's get branch and see the branches that we have in our system now. Now we have the footer branch, we have the master branch, we have the merge conflict branch. I'm going to run my git log dash one line command again, and then let's see what happens. So as you can see, we have created another branch, the merge conflict branch. We have not switched to it yet. The current branch is master because the head is pointed at master. Are you getting it? But now we have created a merge conflict branch, and we are about to make a commit from that branch, and that commit is also going to change the header. So we are going to have this commit on the master branch that changes the header. Then we are going to have another commit on the merge conflict branch that also changes the header. Do you get it? So it's like we are going to have two branches like that. This branch is doing the same thing and this branch is doing the same thing. When you try to merge them, they'll be like, which one do you want? All of us are doing the same thing. Which one do you want? So it's like in our illustration, it's as if this C2 branch and this C5 branch are all doing the same thing. When you try to merge them, they'll fight against each other. So let's switch to the merge conflict branch. Okay, it's at this commit. Then we are going to also change the header. So let's just get out of here. Get out of here. Get out of here. Okay. Okay. So let's get checkout to the merge conflict branch. You get it? Then I enter. Now I have switched to merge conflict branch. Okay. This M you are seeing over here is telling me that I actually have modified files which I have not pushed yet in my master branch, but it's not a problem. Okay. So now let me run the command git log dash one line dash decorate dash graph, so that we see everything that's going on. this command git log -1 line -create -graph. Now, as you can see, the head is now pointed to the merge conflict branch. We have moved the head from the master branch and we are pointing the head at the merge conflict branch. Okay, so now if I go into my project structure, every change that I've made on the master branch over here is just gonna disappear. So all the beautiful things that we did in my portfolio that I'm trying to create, when I refresh the page, it's all gonna be gone. It's all gone because all that is on a different branch, and I'll switch to another branch which does not have those changes. So all those changes are gone. You get it? So now I'm going to make a commit that changes the header on the merge conflict branch. All right, let's do that. So let me go into my HTML file. So much has changed because we are on a new branch. Every change that we made is just gone. So much has changed. Now let's change this heading. We are changing it to Leo's profile. Initially it was get course updated, then we changed it to my personal profile. Now we have changed it to Leo's profile on another branch. Too many changes happening at the same time. Okay, so I've changed it to Leo's profile. I'm going into my command line. Okay, I'm going to get diff to see the changes. I've changed the heading from get course updated to Leo's profile. All right, let's get out of here. Then we're going to commit this change. So we're going to git add our index.html file, git commit -m. Then we are going to say update header. Okay, no problem. We have made a commit in another branch. Okay, now, so I'm going to run the git graph. So I'm going to list all the branches. So let's see what we have. So as you can see, something interesting is happening here. Forget about the footer branch because we left it behind a long time ago. Now we created a new branch at this point. Then we made a commit on that branch that updates the header on the merge conflict branch. However, the next commit on the master branch was also changing the header. I hope you get it. Okay, so we are going to try and merge this merge conflict branch to the master branch, and let's see what happens. So let's get out of here. We are on the merge conflict branch. I told you that if you need to merge into the main branch, you need to check out to the main branch. So we're gonna get check out to the main branch. We have switched the master branch. Now we're going to get merge. We want to merge the merge conflict branch. All right, now enter. We have a problem. It says that auto merging index.html conflict, merge conflict in index.html, automatic merge field, fix conflict, and then commit the result. We have a merge conflict because the changes that are happening on this branch is the same change that's happening on this branch. So how do we fix a merge conflict? Let's run git status. Okay, and let's see what's going on in our git. So as we run git status, you see that everything in our project structure is okay, but there is a conflict that is lurking. There's a conflict that is lurking in the system. Okay, now let's clear this. You see that there is this new indicator over here telling us that merging, it's trying to merge, but there's a conflict, so we need to fix something. The way to do it is to open your code editor. Now you see that inside our code editor, suddenly you are going to see some important markers. And I need you to pay attention here. Okay, look at this less than sign. It's showing you something. That's the first marker. Okay, it's saying that this is where the conflict is showing. Then we see another marker, these vertical lines. Then we see another heading. Okay, so it's showing me the first conflict over here. It says that over here I said my personal profile, and over here I now came to say that get course updated. All right, then over here I'm also saying Leo's profile. So which is which? Now these markers are what direct you to solve the merge conflict. You have to do it manually. The system is not going to help you resolve the conflict for, itself, because you don't even know, it does not even know which one you want. It does not know whether you want this heading, that heading, or that heading. Which one do you want? So it has to leave you to solve the conflict manually. Merge conflicts are solved manually. Okay, so let me show you something in my notebook over here. Whenever you see this less than head sign, which we see over here in our merge conflict, you see that change represents the beginning of the conflicting change on the current branch. Okay, so the current branch that we are on is the master branch, as you can see, and then on the master branch, the change that we have on the master branch is my personal profile. That is the heading that we wrote on the master branch. You get it? Now, the vertical lines that you see over there marks the original lines that are being changed. Okay, so if you go into the file, realize that the original line was git course updated. That was the original heading that was being changed. So that is what the vertical line represents. Write it down. Okay, then this equal to that you see also marks the end of the original lines and the beginning of the changes from the branch being merged. We are trying to merge the merge conflict branch. Okay, the equal to sign marks the beginning of the original lines and the end of the changes of the branch being merged. Okay, so let's go see it. So this equal to sign says that Leo's profile, that is the change that we made on the merge conflict branch. Don't let this confuse you. It's really straight to the point. All we are trying to say is that if it's become a lot in your mind, this is all I'm trying to say. We made a change on this branch. We made a change on that branch. Now the system does not know which change to accept. So go in there and then decide on which change you want to accept. That's all we are trying to say. So let's forget about all the markers and then let's just take the change that we want. So in order to solve a merge conflict, what you do is to first, number one, delete the markers. Okay, delete all the markers. So we are gonna do that. This is the first marker. Let's get rid of it. I don't want this, so I delete it. You see, I've gotten rid of that. And this is the second marker. I don't want it, I get rid of it. This is the third marker. I don't want it, I get rid of it. So now I'm left with get course updated and Leo's profile. Which one do I want? I want neither of them. Okay, all right, or rather let's just keep it as Leo's profile. Let's keep it as Leo's profile. So I don't want the get course updated, so I get rid of it. I'm resolving the merge conflict. You do it manually. That's what I'm doing. Okay, then I scroll up to the next marker, which is over here. I get rid of it. Do I want this heading? No, I don't want it, so I get rid of it. And the heading I want to keep is Leo's profile, so I'm just going to take that and position it where I want it to be, right here. Then I save. So now that I've saved it, let's go into my command line and then we'll git add index.html and we'll git commit. We'll say we resolve merge conflict. As you can see, the merging is now gone. Okay, so let's run the graph command and let's see what we have in our system now. See what happens. Our head is now pointed to master, and then the merge conflict branch has been merged into the master branch. So everything seems okay now. If we go back to our project and refresh it, we are going to have those changes back again. This time around, it is not my personal profile, it's Leo's profile. We have merged the two branches together and we have resolved the conflict. Now, we have come to a very important aspect of this course. How do you undo changes you have already done in Git? You have made a commit message. How do you undo that commit message? How? How do you go back into the history of Git and reset commit? How do you destroy commit? How do you squash them? We're going to talk about all that. Okay, so in order to do that, let's make some changes. Then we are going to find out we've made some changes. How do we undo them? Let's say I was writing a commit message and I made a typo error in the commit message. I want to just correct it. How do I do it? Or I just want to delete the entire commit. How do we do that? Okay, so this is our log, and our last commit was a resolving of a merge conflict. So we are not going to undo that because we went through a lot of work to solve this one. Okay, so we are not going to undo this one because we have to go through all that work to redo it. We are not ready for that. So let's make new commits, and then we'll learn how to undo commits with those new commits. Okay, so let's go into our HTML document and add some style to some of the elements. Let's say we want to add some style to our navigation bar. Currently it doesn't look very nice, so let's add some style to it, and then we'll undo those changes. Okay, so let's say I want my navigation bar to have some background color and padding. Let's say navigation styles. Let's see how this looks. That's okay. Or let's make it a little lighter. That's better. Now let's see if we can add some style to our unordered list. Let's see how that looks. Okay, I think it's not looking bad. Let's commit these changes and then we'll undo it. Git commit -m add style navigation bar. Okay, the other changes which I added, but don't worry about that. Let's just go through the tutorial. Let's get status. See, okay, our branch is clean. So this is the current state of our project. Assuming all this change that we made, we want to undo the change that we just made in our CSS file. How do we undo a change? We are going to undo this commit, and the command you use for it is git commit -- amend. You can use this command to do a lot, but the first thing you can use it to do is to undo a commit you have already done. All right, so we're going to try it out and see how it works. So git commit -- amend. Now it's waiting for the editor so that I edit the commit that I want to make. So the commit message was add style to navigation bar. Let's say I want to change this commit message, so I'm rather going to say add styling to navigation bar. Okay, now as you can see, these were files that I had added in the project structure. Okay, and so what I'm going to do is that I'm just going to save this file and close it, and I've edited my commit message. Okay, so if I go now git log -- one line, you can see that I've edited the commit message, add styling to navigation bar. It's as simple as that. But this command git commit -- amend is more powerful than that. You can actually use this command to add forgotten files to a project structure. Let's say I changed my HTML file and I changed my CSS file, but when I was committing I forgot to add the changes in the HTML. I can actually add those changes to a previous commit without making a new commit. It's very powerful. So let's try that out and see. Let's see if we can add a contact me session. Okay, so let's just add a contact me session to my HTML file. That's before the footer. Let's put it here. So this is a new section that we just added in. No, this is a new section that we just added in our HTML document. Okay, so let's go style it in our CSS and see how it's gonna look. All right, awesome. So let's go refresh our page and see what we get. Okay, that doesn't look bad. So we have created a contact me form. We added a section in the HTML document, and then we styled it in the CSS file, and it looks cool. So let's go commit this change. Yet we are not going to commit the HTML change, only the CSS. So we're going to git add, then we are going to add only the CSS file. Let's commit and say that add contact me form. Now let's get status. You can see that we have modified the HTML file, but we forgot to add it to this commit. Okay, so what you're going to do is that stage the file that you want to add to the previous commit. Okay, so you're going to git add your HTML file. Now we get status, we see that that file is in a staging index now. When you are done putting the file in the staging index, now you want to run the command git commit -- amend. See what happens. Now the commit that we made when we added the CSS file, the same commit has been brought back to us, and we are not going to touch anything. We are just going to save the file and then exit. You realize that the new HTML file has been added to the previous commit. This is what you use the git commit -- amend flag for. It's very powerful. So now let's go run the log of our project and see what we have. So git log -- one line, and as you can see, we have only one commit: add contact me form. Okay, now let's show what was done in this commit. So git show. Before that, let's copy the SHA of that commit. So let's copy the SHA of that commit, and let's git show that commit, and you can see that all the changes that we made, this is in a CSS file, this is in the HTML file, everything is over here. So we have added a new commit to a previous commit. We have added a change to a previous commit. We didn't have to create a new commit, and you can do that. Yes, you can do that with the git commit -- amend command. Very powerful. Wonderful. So now let's talk about what it means to revert a commit. The first one, you amend a commit. You just make changes to it. But this time around, we are going to revert. We are going to undo the changes that we've already done in a commit. Okay. Now, the way to do that is to use the command git revert, and you bring the SHA of the commit. Okay. Now, this creates a new commit. You have to be careful when using it. So let's go try it out in a command line. So let's, of course, we have to git log -- one line so that we can get our SHA. Right, now let's say that we want to undo the last commit that we made. Now remember that our last commit is what gave us our contact form, and then styled it beautifully like this. Now what we want to do is that we want to undo that commit. So I'm going to copy the SHA of that commit, then I'm going to use the command git revert, and I'm going to supply the SHA of the commit. Now see what happens. I am about to revert a commit, and my editor automatically opens and is asking me that, do I want to use this commit message, revert add contact me form? It doesn't sound bad, so let's just use it. So I'm just going to save and close my editor. Now as I come into the file and refresh, you realize that the contact me form is gone. We have undone a commit that we did. All right, now we're gonna run git log -- one line. And you can see that now the previous commit that we made, add contact me form, is there. It doesn't mean that the commit has been erased. All right, there are two things we are doing here. With the first one, we amended the commit, but this particular one, we are reverting the commit. But the commit that we reverted is still in the history of the project. So you can see it over here, add contact me form, and then revert add contact me form. That's a new commit because we have reverted it. You get it? Now let's talk about another very important aspect of undoing changes, which has to do with the command git reset. Okay, this command is not like reverting. This one actually erases a commit, and you have to be very sensitive. You have to be very careful when using it. Resetting commits erases commits. You need to be very careful when using it, and this is the way to use it. Git reset, then you give the reference to the commit, which is the SHA. It can be used to move the head and current branch pointer to the reference commit. It erases commits. It moves committed changes to the staging index, and then you can also unstage committed changes. Okay, but then there are flags that you can use with the git reset command, depending on what you want to do, based on what we have already said ahead. Okay, the way that git determines if it erases stages previously committed changes or on stages previously committed changes is by the flag that is used, and the flags are --mixed, --soft, --hard. Okay, so now you can reset a commit by providing the reference to that commit, and we are going to understand how to do that now. This ~1 you see over here refers to the parent commit. Okay, So now, this is the current commit we are on. The next commit, which is this, is the parent commit of this commit. Does it make sense to you? Now, this is the grandparent commit of the current commit. This is the great grandparent commit of the current commit. Do you get a hang of it? So now, the head is currently pointed at a recent commit, but then this one is a parent of the current commit. The next one is a grandparent. The reason why I'm teaching you this is that you need to know how to reference commits. You can read more on this because it's very important. You need to know how to reference commits. And the way to reference the parent commit is to use the head ~1. It means that I'm referring to the commit ahead. If I use head ~2, it means that I'm referring to the grandparent commit. Okay, so if I use head ~3, it means I'm referring to the great grandparent commit. And this is important for you to reset commit. So the moment I say that I want to git reset head ~1, it means that the current commit I have referenced is going to be used as the base. It's going to be used as the base, okay, to delete the commits that are ahead of it. Now watch this. So assuming I say that I want to git reset head ~1, it means that this is going to be used as the base because that's ~1, the parent commit, and then the commit above it is going to be deleted. Now if I say that you git reset head ~3, okay, so we are going to count 1, 2, 3. So it means that this commit is going to be used as the base, then the commit above that is going to be deleted. We are going to try it out, you see. Okay, so we are not going to touch the reserved. Let's try and delete this commit, the current commit. So we are going to git reset with this as the base. Okay, so I'm going to, since this is the parent commit, it's going to be head ~1. You get it now? All right, so let's now clear my screen. We're going to git reset. Now, which flag do we use? Do we use -- mixed, -- soft, or -- hard? What do these flags do? The -- mixed flag, what it does is that it stages previously committed changes. So you committed the change. When you use the -- mixed flag, it brings the committed changes back to the staging index. The -- soft flag brings the committed changes back to the working directory. It unstages it. Do you get it? Then the -- hard flag deletes the commit entirely. So we are going to use the flag that deletes the commit entirely, and let's see how it goes. Okay, so we are going to git reset -- hard head 1. Okay, let's go try it out. Don't be afraid. So git reset -- hard ~1. Let's enter and see what happens. The head has been moved to the next SHA. It's been moved down and that commit is gone. So let's git log -- line. See where we are at now. Now the current commit is add contact me form. The changes above it gone because we reverted the changes. So let's go refresh our HTML and see what happens. It's back. It's back. These are very powerful commands, but you have to be very careful when using it. Okay, so let's try and do some hard damage to our project. Okay, let's do some hard damage to our project so that you see how dangerous this command can be if you don't use it well. It doesn't mean you should be afraid to use it, just use it with care. That's what I'm trying to say. Okay, so I'm going to git reset and bring it all the way down to when we added the navigation bar. That's way down. It means we are going to delete all the commits ahead of it. Are you sure we want to do that? Let's try it out. Okay, so let's count. The head is currently here. Okay, so you need to determine what is the base you are going to use to delete the commits above it. So let's count. 1, 2, 3, 4, 5, 6, 7. So the parent is head ~7. Okay, so we have 1, 2, 3, 4, 5, 6, 7. So we're going to use that as a base to delete all the commits above. Okay, let's try it out. We're going to git reset -- hard. That's dangerous. We're going to delete head tilde 7. Let's see. Your head is now at that present char. Change header. So let's go to our project and then see. Let's refresh it and see where we are now. Everything is gone. We've deleted all that. Let's run our git log -- one line. As you can see, the head is now at the point where we changed the header. All the changes we made has been deleted. We deleted the commits. Can we have it back? Yes, we can have it back, but it's not that straightforward. There is a command that you could use known as a git reflog command. Git reflog. When you run that command, it's going to show you all the commit references. You may want to cherry pick that to be able to restore, but it's not that straightforward. Okay, or you can also use a command known as git stash. Okay, git stash. I'm going to teach you about the git stash command. All right, now watch this. We already know that in our git system we have the working directory, we have the staging index, and then we have the repo. We already know this. We are advanced now. Okay, when you move the files from the working directory to the staging index, the next step you already know is to move it to the repository with the command git commit. But there is something more you can do. Instead of moving it to the repo with the command git commit, you can actually stash it somewhere with the command git stash. Now what does this command do? It stores the changes in some backstage. So the project is not going to be in the active tracking system, but it's been put somewhere. It's like being stashed somewhere. It's been archived somewhere. Okay, so you can actually go and bring those changes back with the command git stash pop. Okay, so when you run git stash and you are lucky enough to find the commits that you deleted in there, then you are lucky you can pop them back. But you may not always find them there because git deletes the reset commits. When you want to delete your commits, there is something that you should do, and this is called a backup branch. A backup branch. Okay, let me show you how to do that. So let's say now I want to delete. I'm going to come to delete again. I want to delete the project all the way to this commit. Instead of just going ahead to git reset -- hard and then deleting it, I'll rather create a backup branch so that just in case I want to restore the project to that point, all I have to do is to switch to that branch. So let's go create a backup branch. Before we do that, let's run git log -- one line -- decorate -- graph -- all. So you see that our head is currently on this commit, change header. All right, so let's say we wanted to delete all these commits above to the point where we added a .gitignore file. What we need to do is to create a backup branch at the most recent branch. Okay, then if we delete all this, we can always go back to the backup branch. Let's try and do that. So let's git branch and call it backup. Get it? So now when we run the command, we see that we have created a new backup branch and it's pointed at the same place where the head is pointed. So now let's go and git reset 1, 2, 3, 4, 5. Let's say we want to git reset to this point. Okay, so I'm gonna 1, 2, 3, 4, 4. All right, so let's get rid of this. Git reset -- hard head tilde 4. Then we enter. Let's run. And as you can see, the head is now here. Okay, all the commits that were above for the master branch have been deleted, but because we created a backup branch, now everything is over here. And also there was a merge conflict branch, all right, the one that we created before. So all that is here, but assuming there were no other branches but the master branch, all these commits would have been gone just like they were the first time. So it's important to create a backup branch before you Git reset. That is very, very important. So now since I'm on the master branch, when I refresh this, it's like everything is just gone. But when I switch to the backup branch, check out backup. Now I refresh my project and everything is back. Okay. So we have done so much in Git. We have not even come to GitHub yet. This is just Git that we have been dealing with. And look at the amount of information that we have been able to hone out in Git. Now in the part 2 of this video, we are going to be talking about GitHub and collaboration. GitHub and collaboration. You don't want to miss that video. That is even more important than, okay, this is the foundation, but that is also very important if you want to be working with other developers. So what I need you to do right now is to subscribe to this channel, because the video is right here on this channel. All right, I need you to subscribe to this channel and then watch the part 2, which is GitHub. All that we have done is mostly Git. Now let's talk about GitHub. GitHub. By the time you are done with that video, you will be a Git and GitHub pro. Let's go to the part 2.